Okay, let's take a look. Question 6. The diagram below shows part of the curve x equal to half y square. This guy, the line x plus y equal to 4, and meets this part of the curve at the point P. So this is a point P here. You want to find the coordinates of P. How do you do that? Use the GC. Do I need to show?
I don't need.
Only, okay, then I'm just going to calculate it. Okay, make sure your mode is in function mode, not parametric. Notice that this function is x equals something. So if you want to use the GC, you actually need to solve for y. So it's plus minus square root 2x. It's actually two separate functions. Okay, so okay, here the graph, it only shows the upper half. So it means this is actually just the positive square root 2x. Yeah, reject the negative. What do you get as the intersection? Make y the subject first.
Two. X equals to 2, y equals to 2.
2,2. Okay, good. Same. Now how do we proceed? Okay, let me just clean up this. I don't want so much clutter. I'll remove this working. I'll just get the conclusion here and here. Okay, so this is the two functions. They intersect at 2, 2. Part 1 done already. How about part 2? The exact area of region A. What would you do? Now over here, the exact region of region A, I hope you realize that if you try to integrate with respect to certain axis, it will be easier. Which axis do you think you want to integrate with respect to?
X.
With respect to x, actually, not so smart. Over here, let's see. If you try to integrate with respect to x, what will you get? Here, then here, then here. Region A is this region. Can you see?
Yeah.
Who is on top and who is below with respect to x?
Region A, like the
For
y.
region A.
The y equals to 4 minus x.
Is the top or bottom?
The top.
Top. Y equals 4 minus x. Bottom is the other guy.
Yeah. Square root 2x.
So here, what do you need to do if you want to find the area? You actually need to find out this intersection here. Then you find top minus bottom, right? Then you can get your region A.
Yeah.
Then for region B, let's say you found it already. Then how about part 2, region B? You want to find the ratio of the region A to the area of region B. So basically, you need to find the area of region B. But this, let's say we continue with respect to x. Would it be a good idea? Okay, I mean, sorry.
I use the triangle, then I minus what I found in part 2.
Yes, can also. You take a triangle minus away the part A. Then you can get area of B. That is actually faster. Yes. Then after that, you take the ratio. Okay, so actually maybe with respect to x-axis, it's not that bad. But the point of this question is actually for you to use the y-axis instead. Do you know why?
No.
Okay, the reason is if you think about it, parachutist is here. Gravity is going downwards in this direction. Oh, then with respect to the y-axis, if you want to find the region A, you just need to actually maybe you just need to add these two areas. Can you see? There's a top half and a bottom half.
Yeah.
Purple color and okay, this one cannot see. Maybe yellow color. Can see?
Yeah.
Purple and yellow. It's actually a little bit faster, I guess. Oh, by the way, do you know how to solve for 2, 2 here manually? With our GC?
Like sub in.
Yes, correct. Just sub y equal 4 minus x into x equal half y square. And so on and so forth. I don't go through. Is that okay?
Yeah, can.
Okay. Then exact area of A, let's do that. Okay, let's begin. So question 6, part 2. You want exact area of A. So what you realize is that you should integrate with respect to y. Let's just try that out. Then you try to find the yellow region and the purple region. So the yellow region here, this shape, the area, is really just equals to the integral of, first you need to identify who is on top and who is below. Can you see? The parachute, the person dropping down from right to the left, there's a top and there's a bottom. So maybe if I just use a different color, let's say I use pink color. This guy is top. This guy is bottom. Which means that all I need to do is to integrate top minus bottom, which in this case is x equal half y square. So I write down half y square minus away 0. Because this is x equal to 0. This guy is x equal to 0. That guy is x equal half y square. All right. And when you're integrating with respect to y, you always have x as a subject. Okay. So in this case, you don't even need to do algebra. So it saves a bit of time. Then, but here are the limits. You integrate from something to something. Who do you look at? X or y coordinate?
The y.
The y coordinate, because now it's with respect to y dy. So what's the lower and upper limit?
Is 0 and 0 to 2.
Yes, correct. It's 0 to 2. But take note over here, the reason why it's 2 is because you're looking at the y coordinate 2, not the x coordinate. Okay? Oh, this one. Okay, that's the first region. Then you add on the second region, which is the purple one. Maybe I should write my working like this. What shape is the purple region? What shape is the purple region?
Triangle.
Triangle. So half times base times height. What's my base? What's my height?
It's 2 and 2.
4 minus 2 is 2, right? This guy is 4 minus 2 equals 2. Okay, so half times 2 times 2. Then there you go. I think this is a little bit easier. Compared to the other integral you are trying to go for, with respect to x, it will be integral of 4 minus x is the top guy, the straight line, minus away the curve, which is square root 2x. I mean, still doable, but a bit long-winded. 0 to 2. You see, because there's a square root 2x, you have a power half. Then when you integrate half, you need to make sure you add 1, get the new power, divide by new power. 3/2 divide by 3/2. So you have to be careful with this one. Can get still the same answer lah. Oh, just more long-winded. Here, I think it's easier to integrate this. Let's see. Half y square, take out the half, integrate y square. 0 to 2 dy. This one, half times 2 times 2 is just a 2. Leave the half alone, integrate y square, get y cubed over 3. 0, 2 plus 2. Sub 2 cubed over 3 minus 0 cubed over 3 plus 2. Of course, this one straight away you can see it's equal to
0.
0. So you can replace it with 0. So half times 2 cubed is 8/3 plus 2. Simplify 8 and 2 cancel, you're left with 4/3 plus 2. That's 3 and 1/3. Of course, you can just use a GC calculator by now. This will be 10/3. Can?
Can.
Okay, moving on. So now part 2, how do you find the ratio? Sorry, part 3, I mean.
Must find region B.
Yes. Find B. Then ratio A/B. So area of region B is equal to what? You mentioned already. It's referring to this big triangle.
Yeah.
Minus
So
away
it's
A.
times 4 times 4.
Correct. Minus 10/3. Simplify, calculator for this. 14/3. And therefore ratio is, okay, maybe I don't write ratio first, I just write A/B. A is 10/3, B is 14/3, so the ratio is 10/14, which is 5/7. I is to 7. Can? Not that bad, huh? Okay, good. Now we try the next one. Oh, this one question 7 go through already, right?
Yeah, the parametric.
Parametric. Okay, skip. Question 8. Okay, I skip first. Question 10. Let's see. That was homework. Okay, let's read the question. So question 10. Oh, by the way, I sent an updated file last night. Question 8 was modified.
Oh, okay.
Yeah, just take note of that. Go and download the new one. So question 10. The region bounded by the curve y equals x squared plus 1, the x-axis, the y-axis, and the line x equals to 2 is rotated completely about the x-axis. So this is volume of revolution question. Find the volume of the solid form. How? Recall what's the formula? V equals to?
The y, like the fx square minus gx square.
Good. Fx square minus gx square. What else?
Pi.
Pi in front. Very good. You miss out the pi, it's gone. Must remember this. How about here? A and B. Lower and upper limit. So basically a shape that looks something like this. Some squiggly line function and another squiggly line. F of x on top, g of x below. And it's bounded in between by two regions. Let's say here, x equal to A, and it happens to be a point of intersection, for example. And here, x equal to B. Then you got the region here. Then what you do is you rotate this about the x-axis. So you can, I don't know what shape this will be, but you'll get some very weird shape eventually. Okay, Ken, moving on. So let's just use this formula. Draw the graph first. We got y equal x squared plus 1. So how does it look? it must look like something like this. Oh, there's a 0, 1. And you're saying you want the region that's bounded by the graph, the x-axis, the y-axis, which is x equal to 0, and the line x equals to 2. So where is the region? Over here, lor. Right? So let's just draw that in. Coordinates here, sub x equal to 2, 2 square plus 1, 5. Region here, then we just draw a fancy circle like this, like this, to remind ourselves we are rotating about x-axis. So find the volume now. Use the formula pi times integral lower limit x equals
0,
upper limit x equals
2.
what's in between?
The x square plus 1 square.
Minus?
0.
Yes, 0. Of course, if you know, you can skip this. If it's with respect to the x-axis, the x-axis is always equal to 0. So that's why this will always be gx equals to 0. So minus 0 square, you can just ignore it. But I like to just remember the general formula. Easier. Don't need to remember so many things. Simplifies back down to this guy. You don't need to write the x equals. I'm just writing it to remind myself, oh, I'm integrating with respect to the x. Okay, good. Then how to integrate this? Do it manually. So this one becomes power 4, 2x squared plus 1. Integrate 0 to 2. Integrate term by term with square bracket. Become power 5 divided by 5. 2x power 3 divided by 3 plus x 2, 0. Sub in, you get 2 power 5 over 5 plus 2 times 2 power 3 over 3 plus 2 bracket minus away 0 plus 0 plus 0. What do you end up with? Hey, did I go through this before?
I don't think so.
Can't remember. Looks familiar to me, but I can't remember. Sorry. Yeah, so this is your answer. Units cube, Okay. Can. Next. Practice. Now is the time for you to practice. Try it on your own. Take out a piece of paper and pen and try this on your own. Practice. Region R bounded by the curve y equals 2 over x and the line y equals 2x, x equals 0, and y equals 4. Find the exact area of the region R. That's part 1. And part 2 is volume of solid form when you rotate completely about the y-axis. Oh yeah, by the way, rotate completely is the same as rotate by 4 pi over 2 radians. 4 pi over 2 radians means 490 degrees. Basically, one full circle.
Okay.
Yeah, sometimes the question will phrase it like that. Very funny. Try. Okay, so I'll start giving some hints. I'll continue doing. Okay, I'm sure by now you would have drawn the graph. No?
Yeah.
Ah,
Draw.
yes. Good, good. You'll probably need to find the coordinates of this point of intersection.
Is 1, 2.
Good. So y equals to 4, where is it? Somewhere here. Oh yeah. Once you're done with part 1, please take a photo and send. And shout into the microphone so I can know.
Okay.
Are you integrating with respect to x or y?
Y.
Okay, good choice. What do you need to take note of in the integrand? Is it x equals or is it y equals?
Y equals.
So you just put in a 2x here. Y equal to x. Then you put in 2x. That's wrong. Letter here different. We are not doing separation of variables here. No, cannot. What do you need to do as your first step? If you want to integrate with respect to y, make x the subject. So x equals to half y. X equals to 2 over y. Then you work with half y and 2 over y. Is that clear?
Yeah.
Then you figure out who's the top function, who's the bottom function. And whenever you're ready, send in. Done?
No.
Oh no.
But I get negative unless I integrate wrongly.
Probably so. Who is top and who is bottom? Let's do you realize that there are two separate regions here?
Yeah, I like separate into two.
0, 2, then 2 to 4, right? So how to find the first region? Let's just split that up as R1 and R2. Can understand? R1 at the bottom, R2 at the top.
Yeah,
So what is R1?
the 0 to 2. The
What shape is this?
triangle.
Don't need integration. Half times 2 times 2. Half times 2 times 1. Okay. Height 1. Sorry. More like base 1 and height 2, which is just a 1. Alternatively, R1 can also be calculated as the integral of what is it? This guy here, which is x equals to 1. So we integrate 1 with respect to y, but it goes from 0 to 2. So y equals 0, y equals to 2. Integrate, you get a y, square bracket, 0, 2. This is equal to 2 minus 0. Did I do something wrongly? Let me see. Oh, sorry. No. This is not y equal to 1. Sorry, the top function is this guy, right? Which
Yeah.
should be x equal half y. So let me try again. This should be a half y. Integrate, you get a y square. Is that right? It will cancel off with the half. Let me think. No. It should be y squared over 4. Oh my goodness. Is that right? Yes?
Yeah.
Yes, okay, good. Can. Then you sub in 2 square over 4 minus 0 square over 4, which is just 1. This is the integration way to find the area of a triangle. A bit overkill, don't need. Let's just move on to R2. So how to find R2?
I integrate 2 over y.
Sorry?
I integrate 2 over y.
2 over y
Then it's 2
dy.
to
2 to 4. Okay. 2 to 4. Can, correct. Good. Carry on. Why would it be negative? That's a bit weird. 2 over y.
never mind, because I use the volume.
No, we're not at volume yet. Part 1 is just asking for area, huh? Oh, use wrong formula. Okay. Read the question.
Okay, I tell you already.
Oh, hold on. Let me move my screen around. Okay, wait, let me go download. Let me see. What does this say? So you integrate 2 over y, get 2 ln y. Technically, there should be a modulus around the y. But it's 2 to 4, so it's fine. You can drop the modulus. It will still be positive y. Then y will still be positive. Don't need modulus around the y. So sub in, then you get ln 4 minus ln 2, correct? You get ln 4 over 2, yes, which is ln 2. 2 ln 2, perfect. Then you just need to add them together. Yes, good. Okay, part 1, okay. Move on to part 2. Go. Part 2. Volume of solid form when R is rotated completely about y-axis. So about the y-axis, so you draw a fancy circle like this. To remind yourself you're turning about the y-axis.
Okay.
So over here, a point to take note that I should mention is that here is a very sharp point between these two curves, right?
Yeah.
You're going for fx and then gx, top minus bottom. But you realize the top is two separate curves because they are connected at a separate, very sharp point. So it's a smooth curve here, then suddenly you have to turn around a lot and then you can continue going down. So that means you actually need to find volume of revolution 2 times. The first R1 you rotate, R2 you rotate again. Then you add them together. Right? If not, who's your top square? Then minus bottom square. Who is your top? This entire thing. It's not a smooth curve. So must do it separately.
I minus 0 square.
Correct. Because x equal to 0. Yes, that's a good choice. But the top, you have to be careful. That's just a hint. Whenever you're ready. Whenever you're ready.
Yeah, I send you.
Okay. Oh, have you sent it?
Wait, I'm taking the picture.
Okay.
Yeah, I send you already.
Okay. Let me finish my drawing. Something like this. You're rotating this thing about the y-axis. Can you understand whatever I'm drawing?
Yeah, can.
Okay. Let me check your working. Hold on a second. Okay, let me download it. Okay, so you integrate pi from 2 to pi times integral from 2 to 4 of 2 over y bracket square dy. Good. Then you add on pi times integral from 0 to 2 of half y bracket bracket square dy. Okay, good. Yes, correct. Your setup is fine. Then the rest, okay, I'll just check the details. 4 over y 2 y power -2 at 1 become -1. That's not correct. 2 over y bracket square. Your second line wrong already. Let me just double check. Yeah, here your set. Your don't need v1. Just v can already because you straight away added together. Pi from 2 to 4 of 2 over y bracket square dy. This is really just 2 square over y square, which is 4 over y square, which is actually just 4 times y power -2. Y power -2, add 1, get the new power, divide by the new power. What do you end up with? 4 times y power -1 over -1. Here there's a power -1. What do you this is the part that you missed out on.
Oh.
Right? So should be -1 and arrow carry forward. I don't want to go through. You know the rest. So your half y square, you get after expand it, you get y square over 4. You are differentiating or something? Wait, no. Sorry. Oh, correct. Your second integral is fine. Just take note, should be a -1 power. Okay. Then yeah, so basically when you rotate about our axis, you just think of it like this. Rotating some area, then you rotate 3D. Then you eventually get a 3D shape. I don't know what it is. You can go visualize yourself. Then in this case, yeah, you just need to make sure you integrate correctly and get the correct limits. The important point to take note from this example is that here the top function, the fx square, then minus the gx square. Gx square is just 0. But the fx square here is actually made up of 2 functions, f1 and f2, because they are connected at a very sharp point. So you need to find the volume of revolution separately. Separately as in the first guy plus the second integral. 0 to 2 of what is that guy is half y. Is it half y? Yeah, half y bracket square dy. Okay, moving on. So 8 skip, 9 skip, hand, practice, question 11, question 12. Okay, go through. Okay, let's do this question together. So there's question 11. The region R is bounded by the curve y equal to x times x minus 2 and the line y equal to x. Find the volume generated when R is rotated completely about the x-axis. So for this question, you must first draw the diagram as well. All the integration questions need to draw a diagram, just like vectors. So x times x minus 2 looks like this. Intersect at 0, 0 origin and 2, 0. Then over here is a turning point. What's the x coordinate of this turning point?
1,
1,
0.
exactly. Then 1 comma sub in x equal to 1, you get 1 times 1 minus 2, which is -1. Oh wait, that doesn't make sense. Let me think. Did I do something wrongly? 1 times 1 minus 2. It's a -1 times 1, which is a -1. Right. Sorry, this question is wrong. I copied the question wrongly. Can you help me to make a correction here? I meant for this to be a 2 minus x.
Oh, okay.
Sorry. That makes more sense. That's why it should be a set face. X times -x. Then you get -x squared. That's why it's a set face. Help me to make this correction.
Okay.
Yeah, just take note. So you sub in x equal to 1, then you get 1 times 2 minus 1, which is 1 times 1, which is a 1. Okay, good. Then you have a line y equal to x. Okay, since this is 1, 1, what do you know? The y equal to x must pass through. Of course, all this information can be deduced from our GC. Don't need to do so much work. So let me just adjust. Okay. All right, then what's the region they want? Must be this region here. Can see region R. Okay, then you want to find the volume of revolution when it's rotated about the x-axis. So how do you do that? First, you identify parachute, the guy with a parachute. The gravity is dropping this way, dropping this way. So who's the top function? Who will he first land on? Must be this guy here. This guy is the top. Who's the
Yeah.
bottom? The other guy there. So I'll just label top, bottom. Then just use formula. Volume equals pi times integral from top function, which is in this case x times 2 minus x. Bracket, square, don't forget the square, minus way, bottom square. In this case, bottom is y equal to x and dx. Here, I don't need to make x the subject because we are integrating with respect to x. Then what's the upper and lower and upper limit?
0 to 1.
0 to 1. Good. Because we focus on the x coordinate here, 0 and 1, because it's with respect to x, rotating about the x-axis. Okay, Ken, simplifying this, what can we obtain? Well, okay, we can just I'm going to skip the working. Is that okay?
Yeah, can.
I'll leave that to you to work it out. The final answer will give you a 1/5 pi. Okay, because this is just integration technique. Oh, you need to square this, then square this, you subtract, then you simplify, then you just integrate term by term. I'm sure you already know this. I don't want to go through. We focus on the setup. And that's the main point of application. Don't waste time on the techniques anymore. You know how to do the techniques already. Just do it carefully. Let me mark your work if you want. If not, I'm just going to move on. That's 11. Done. Question 12. Let's go. The diagram shows. Oh no, I didn't include a diagram. Never mind, you can draw yourself. Okay, so this diagram that is not shown shows the shaded region R bounded by the line by the curves y equal to x squared minus 1, y equal 3 plus x power 4 over 4. Show that the area of region R is 34 over 35. Okay, so the region that I left out here, that I didn't draw for you, is this guy. Just use a GC and you can get the same graph. It looks something like this. X-axis here, y-axis there, origin. Then you got y equal 3 plus x power 4 over 4. So it looks something like a quadratic curve, but steeper. Then you have the other guy, which is oh sorry, no. Mixed up. No. This is 2x squared minus 1. And it intersects at -1 here. Then the other guy, 3 plus x power 4 over 4. It looks something like this. Intersect here, then it curves downwards. And then it has a symmetry going on. Let me try to make it symmetrical. Ooh. Okay, basically you can get this graph from using the GC. Let me try and make this a bit more accurate so it looks nicer. Okay, and then I need to cut here. Yeah, okay, can. So this is y equal to 3 plus x power 4 over 4. Can see? The two graphs? Okay, now. Okay, good. Then the region R, where is it? It's this region over here, light blue. Inside. This is region R. Then what do we want? We want to show that the area is 34 over 35. How do we do that? You just need to use GC. You just need to use the GC. Using the GC, we figure out that this point of intersection is actually -1, 1. This point of intersection is 1, 1. Okay. So how do you find the area of region R? Now, one point to take note is, can you see that it's a top and a bottom?
Yes.
So every time there's top and bottom, regardless of whether it overlaps the x-axis or not, you can just use the formula top minus bottom and integrate the correct what do you call it, limits. So in this case, area R, or just call it capital R, equals to integral from, do you need a pi? Area?
Area don't need.
Area don't need, very good. So integrate from what to what? Let's say dx.
-1 to 1.
Good. Then the top function is?
The y equals to 3 plus x to the power of 4 over 4.
That's the top. Minus away.
2x squared minus 1.
Missing pair of brackets here.
Mm.
Invisible pair of brackets. So you need to bring the minus in. Then over here, you can just use the GC. You can just use the GC. Do you know how to type the integral on a GC?
Yeah.
Math 9. FNINT. Okay, just look out for this. Yeah. Then you eventually get to 34 over 35, over 15 using a GC. All right, good. That's part 1 done. Part 2, Part 2 is find the volume of the solid obtained when R is rotated through 2 right angles. Sorry. When R is rotated through 2 right angles about the y-axis. What does that mean? 2 right angles about the y-axis.
180 degrees.
180 degrees. Can you see that this shape here spans across 2 different planes? Like the left half and the right half, I mean.
Yes.
So if you turn 180 degrees, you'll just end up with a volume of revolution. Okay? You just get a full solid circle, full solid shape. Is that clear?
Then what if it's like 360 degrees?
If it's 360 degrees, then you overlap already. You see, you imagine a satay stick. This is like a piece of satay meat. Then you turn 180 degrees. You sweep out the entire region already. If you turn another extra 180, you're just doubling it. Then in that case, the volume, although there is overlap, we don't go and double count. We'll just treat it as if it's the volume of revolution, as if you turn the entire region.
Oh.
Can you see or not? 180 degrees is all you need to get the entire volume.
Because it's like in 2 regions. Then just now the question, it was in 1 region, is it?
Yes, correct. It's only in 1 region. So you need to make 1 full 360-degree turn in order to go back to your original position. But for this one, it's symmetrical. It's actually also not just because it's 2 regions, it's also because it's symmetrical. When this region turns 180 degrees to the other side, this right half will also turn 180 degrees in the other direction. They sweep out the same region. So they will end up being a solid volume of revolution. So basically, this is just a tricky way of telling you find the volume of revolution. Can you see that shape?
Yeah.
Then how do we do that?
The top minus bottom. Like top square minus bottom square times pi.
But it's rotated about the y-axis. So what should we do first straight away? Can we use y equals?
Cannot. Must
Cannot.
x the subject.
Yeah, so let's quickly do that. 2x squared equals to y plus 1. Divide by 2. Y plus 1 over 2. Then square root plus minus square root y plus 1 over 2. Oh no, there's a plus minus. Which one do we use? Which is plus, which is minus? See, you read this, x equal positive something, ... or x equals to negative something, ... We are looking at this graph, right? When is x positive and when is x negative? Can you highlight for me? When is x negative in this region?
Yeah.
Yes. Or rather, this part of the graph, right? This part of the graph. So whenever you try to find the volume of revolution, right, you just need one of those shapes, and usually you will go for the positive one. Because eventually what happens to the function, you're gonna take x square, right? Remember? You're gonna square it, so the plus minus actually doesn't matter. Okay? Same thing with the other guy. You also don't care about plus minus because you're eventually going to square it. So let's take a look. So times 4 over 4y equals 3 plus x power 4. X power 4 equals 4y minus 3. Here, if it's power 4, complex numbers tells you that you should have how many roots? Power 4 got how many roots?
4.
4 roots, yes. But here we are dealing only with real numbers. Complex number questions are in complex number questions. They will not interact with all the other topics in H2 Max. So you can just assume that there is only 2 roots, plus minus 4th root of 4y minus 3. Whenever you take an even number root, like 4th root, 6th root, 8th root, 10th root, then you just consider plus and minus. That's all. Okay, good. Then it doesn't matter whether it's plus or minus because we're going to square it anyways. So keeping that in mind, let's find the volume of revolution now. So V will be equal to, let's just take, oh, right, I need to do one more thing. Here you notice that if you just take top square minus bottom square, then you then you integrate from whatever to whatever, and then you multiply by pi, it's not good enough. Do you know why?
No.
This is top graph. That one is bottom graph. Do you notice that there's an overlap? There's a horizontal line here.
No.
Can see or not? There's another hidden bottom graph over here. Can you see? You draw your parachute, this or whatever you call it. Then you visualize. Okay, I move him around. You see? If he moves horizontally from the right to left, he first lands on the purple. Then he continues going down. He continues going down. Who's the bottom now? Is the bottom x equal to plus minus square the positive square root y plus 1 over 2?
No.
He keeps on landing on x equals to 0. Can you see or not?
Yeah.
Here. So that means that you actually need to split it up along this graph here. What's this point here? It's 0, 3 over 4, right?
Yeah.
X equal to 0. So that means that if the parachutist is going downwards as in when the gravity is in this direction. From the region -1 to 3 over 4, the top graph is the purple one, and the bottom graph is maybe I'll use light green. Here. Okay, light green. Whereas from the region 3 over 4 to y equals to 1, let me draw another horizontal line. This is y equals to 1. From the region 3 over 4 to y equals to 1, the top graph is purple, and the bottom graph is this dark green line. Can see or not?
Yeah.
Okay, good. So that means that I have 2 separate graphs. Top, bottom, top, bottom. So with this in mind, let's do the integral. You have to split it up into 2 separate integrals. First one would be pi times integral from here to here. Can you see? Maybe I extend it a bit more. -1, 3/4, oops, and 1. So the first region is from -1 to 3/4. Then the second region will be from 3/4 to 1. So first region, -1 to 3/4. What square minus what square? dy?
-1.
Top minus bottom. First region here.
The 2x square minus 1 square.
Let me see. Nope, you're integrating with respect to y, so you need to make x the subject.
Oh, the y, the square root of y plus 1 over 2.
Yes, correct. Then you square. Of course, they will cancel off with the square. The next one?
The 4 square root of 4y minus 3.
Wrong. Look at your parachute. I draw a horizontal line to split it up already. From the region, -1 to 3 over 4. Look at the parachute again now. This guy, he lands. Who's the first function he lands on? Purple. Purple is?
The 2x, the y plus 1 over 2 square root.
Good. Purple, he first lands. Then he continue going down, right? Horizontally. Who does he lands on now? Light green, right?
The x equals to 0.
Yeah, so that's why here it should actually be a, sorry, let me move my parachute away. Here it should be a 0. Can see or not? Do you understand my parachute analogy?
Yes.
First you drop the parachute down, then the top function, and then the bottom function. Who does he land on first? That's your top. Land on second, that's your bottom. Okay, good. That's the first region. You still need to add on the second region. Pi times integral bracket square minus bracket square dy. Fill in the blanks for me. What to what?
3/4 to 1.
Yes, 3/4 to 1. So now you look at the region 3/4 to 1, this part here. This part here. So what square minus what square? I labeled for you top and bottom already, actually.
The square root of y plus 1 over 2.
Square root of y plus 1 over 2, correct.
Then minus the 4
Square it first, then minus away what?
The 4 square root 4y minus 3.
The fourth root of 4y minus 3. Yeah. Yeah, okay, you got it. Good. Just to make it, I don't know if it's confusing or not, I'll color code it. This guy is purple, this guy is green, and that guy is purple again, and that other guy is mud green. Mud. Okay? Purple minus light green, purple minus mud. Can?
Okay.
Okay, now this one you can just use a GC to calculate. Don't need exact. You get 2.62 unit cube, 3SF. Okay?
Okay.
GC. Okay, moving on. So the setup is the most important part. The setup is the most important part. I'm not interested in your integration technique now. I want application. Okay?
Okay.
Question 13, let's take a look. Let R be a region in the first quadrant bounded by the curves y equals x plus 2, y equals e power x. If the line x equal to c divides the region R into 2 equal areas, find the value of c. So maybe I should draw the diagram first. Just maybe you should also type inside your GC quickly the two functions. Is this what you got?
Yes.
Okay, good. Then where is region R? I hope you can see that when I say the first quadrant, I mean this guy. This is Q1. That's Q2, then Q3, then Q4. So the region R is actually, can you try shading in on on Zoom? Which is region R? Where is
Here?
region? Here, very good. Do you need to include this tiny part here?
No.
No, very good. Okay, let me just shade it in now. I don't shade it in, I'll just highlight like this. Okay, can. So region R found. What do they want? They say the line x equal to C divides the region R into two equal areas. Find the value of C. Very interesting question. What does it mean? It means that we have this x equal to C. It doesn't have to be the midpoint. It is not, definitely not the midpoint between 1.1462 and 0. Definitely not. If x equal to C, it splits the region up into a left half and a right half. Can you see?
Yeah.
Yeah, color it purple and then yellow. So they're telling you purple equals to yellow, the area. Find the value of C. How?
Must find the area first.
Sure, okay. Of which region? Region and the entire region are?
Yes.
Okay, can, good. Do that. Tell me.
Oh,
What would it be?
0 to 1.1462.
Yes.
Then the the x plus 2 minus ex.
Much better. Good, good, good. Then this one can be, you can use a GC to calculate numerically. Okay, you can use a GC to calculate numerically. Let's see, what do you get? What do you get?
0.80307.
Good. Okay, we just use 5SF can already. Then that is region R. Then what do we want? We want to find the value of C. We know that purple is equal to yellow. Then how?
Like divide by 2 first.
Divide by 2 first. Okay, so half R equals to half times 0.80307. So how to continue?
Like integrate 0 to 2.
2?
No. Integrate 0 to C should be equal to integrate C to 1.1462.
And then it's the exact same function, x plus 2 minus e power x, right?
Yeah.
That will work. You can work it out, but I strongly don't recommend it. Reason being, you would need to what would you do it? What would you call it? You need to somewhat manually integrate this like 2 times, and then you sub in the limit 2 times. That is a smarter way. This guy here, okay, this works, but not recommended, not the fastest way. You can try it on your own. But the faster way will be integrate from 0 to C. Why 0? Because 0 is nice. 0 is very easy. You sub in 0, very easy to calculate. This 0 to C is just the purple region. Do you agree?
Yeah.
So this purple region and this yellow region are equal. So doesn't it mean that this purple region is just half of the R? It's just this guy, right? Then I don't need to calculate two different integrals, right or not? Makes my life easier. I already calculated one integral, then you still need to do two more. No. Skip
Oh,
this one.
okay.
Just start in with half
Mm.
R. Then you can solve for C. Okay, but this one, let me just show you how to do it. Integrate. So you get x squared over 2 plus 2x plus, minus e power x, 0 to C, equals to the guy on the right. Do I need to explain this part?
Mm.
Don't need. Okay, good. Then you just sub in. So c squared over 2 plus 2c minus e power c, bracket, minus away. 0 squared over 2 is 0, plus 2 times 0 is 0, minus e power 0 is 0. Wrong. It's actually a 1. Are we clear on that? Minus 1?
Yeah.
Anything power 0 is 1. This one a lot of students miss out. Equals to half times of whatever. Okay, then you just try to solve for C using a GC. No choice one. You cannot solve when the C is a power here and then it's a algebraic here. You cannot solve for C manually. Use the GC. How? Let me demonstrate a bit. Have you copied down this function? We're gonna graph this guy. Y equals to c squared over 2 plus 2c minus e power c minus 1. And we're gonna graph that's y1, then y2 equals to half times of whatever. Take note that this is optional. You do not need to write this down during exam. Just say using GC. Just say using GC, C is equal to, let me just give you the answer for 0.415. Okay, ready? Then I'm gonna, whenever you're ready, let me know, then I'm gonna change screen.
Oh yeah, I copy already.
I'll copy already. Good. Okay, I'm gonna change screen now. Can see the GC? Okay, good. Let me just clear screen first. Clear. Go back up. What is it? What do I want to say? Yes, I want to draw the graph. So c squared, in this case, of course, we cannot have c squared, we have x squared instead. X squared, fraction 2, plus 2 times of c, or in this case, variable x. Oh, don't need a second. Minus e to the power of c, or in this case, it's x, minus 1. Then the bottom function 0.5, that's half, multiplied by 0.80307. Never mind, type it manually. 0.80307. Close the bracket. Then you draw the graph. Here, my graph drew very fast. Do you know why?
You lower the resolution.
Yes, the window express equal to 8. I make sure it's here. It's okay to have a low resolution because all I need is the point of intersection, which you can clearly see is over somewhere here, I think. Let me see. Did I do something wrongly? Because I'm expecting a positive answer. Oh, right. I did something wrongly. Minus -1 should be a +1.
Yeah.
Minus -1 should be a +1. Oh my goodness. I am so sorry. Change this to a plus.
Okay.
I'll change it later in the GC. I mean in the iPad. But let's just draw the graph first. So you can get the intersection. So just zoom in on the, let's just zoom in on the diagram. Here, what did we notice? We know that the C, right, is inside quadrant 1, right?
Yeah.
So that means C should be positive. So even though I see an intersection here that's negative, I will just ignore it straight away. That's an answer I will reject. So I'll just maybe zoom in from here, then stretch to the right, stretch to the bottom, press enter. So I get two roots there and there. What do I do? Second calc, number 5 for intersect. For intersection, if you want the left root, you move closer to the left. Press enter. Don't need to move to the left. This is not finding the root. You can just go directly below. You see the 2 points are directly below. It's fine, just press enter. And you get the first root, 0.4147, which is rounded off to 0.415. The other answer would be, let me calculate it. Let me see. Maybe you should record this down first. Have you recorded it?
Yes.
Okay, then let's look at the other solutions. Second, calculate number 5. Oh, sorry, I need to second quit first. Second, calc number 5 for intersect. Move a bit more to the right, closer to the second root. Enter, enter, enter. You get a 1.682431. Okay. So I'm changing already. So that means we have two possible answers for C. C equal to this or C equals to this. Which one do we reject? We reject this one. Why? Let's look back at the diagram. Why do we reject 1.68? We accept this one.
It's already outside the 1.14.
Very good. Yes, exactly. C must be. So here we should write down inequality for C. 0 less than C less than 1.1462. Okay. So straight away we reject this guy. Then we accept this guy. Rounded off to 3SF, 0.415. Okay, that's how you solve this question. Interesting question. Okay, next part 2. Write down something. Write down the equation of the two curves when they are translated by 2 units in the positive y direction. Graphical transformation. How? Translate 2 units, positive y direction. Do you change the x or do you change the y? I mean, sorry. Okay, just tell me what would the resulting function be?
Y equals to x plus 4.
Yes. Y equals x plus 2 transforms into y equals x plus 4 and y equals e power x.
E power x plus 2.
Very good. Yes, correct. Good. Can. That's easy. Then hence, find the volume of the solid generated when R is rotated completely about the line y equals -2. How? So you need to visualize what's going on. Here is y equals -2. Okay. Then what you're doing is you're rotating instead of about the x-axis, which is y equals to 0. Usually it's about y equals 0, right? But now we are trying to rotate about the y equals -2. Can you visualize that?
Okay.
Can. In that case, what we usually do is we try to shift the y equals -2 back to the origin, back to the x-axis. So basically, you take this shape, you look at its relative distance, right? If you try to rotate it about y equals -2, it is equivalent to taking the graph, you shift it upwards by 2 units, and then you rotate about x-axis. Maybe I draw for you on a separate diagram. I think it will be more obvious if I draw a nice diagram. What I mean is, this is before. Then after, what do we want? After we want to take this diagram, then we shift the y-axis down by 2 units. We shift the x-axis down by 2 units. Do you see what I just did?
Yeah.
By shifting the axis down by 2 units, it's equivalent to moving my graph up by 2 units. Can you see now?
Okay.
X-axis, y-axis. I'm trying to rotate about the y equals -2. But now the y equals -2, by shifting my graph around, it looks like my y equals -2 is now the x-axis. So I just need to rotate about the y equals to 0 x-axis. But with the new graph, because now they have all moved upwards by 2 units. So this becomes e power x plus 2, x plus 4. So now the question is really asking you to find the volume of revolution about y equals to 0, the x-axis, with the new functions from part 2. Make sense?
Yeah.
V revolution about y equals -2 of y equal e power x and y equals x plus 2 is exactly the same as volume of revolution about y equals to 0 of y equals e power x plus 2 and y equals x plus 2 plus 2. All right, so that's what we're going to do now. We're going to find the volume of revolution of this guy about the x-axis. But take note that it's only within this blue color region. Okay, so let's do that. So v will be equal to pi times integral. What's the limit?
0 to 1.1462.
Yep, correct. So 0, 1.1462. What's inside? X.
The x plus
Open bracket.
4. The other x.
4. Close bracket.
Then the
Volume
y.
of.
The
Do you
e,
sorry. Do you mention a square?
yeah.
Remember? Oh, sorry. Maybe I didn't hear you. Sorry.
Then the
Next one.
ex plus 4 square.
Plus 2, you mean? Plus 2. Right. Just now you told me plus 2.
Oh, yeah.
Oh yeah. Not plus 4.
Okay.
Close bracket, then square. That's the answer. You just need numerical answer. Just sub in the calculator. You'll get 20.3, I think. Units square. Clear? Understand? Can
But actually the y equals to -2. So
Ah.
I don't add another 2 to it.
No. What do you mean? The -2 is now the same as 0. Then each of these graphs, I just plus 2, plus 2.
Oh, okay.
Oh, sorry, this one plus 2 is your plus 4. Yes, you told me plus 4, right? Sorry, I didn't write it as plus 4. I just wanted you to see the pattern. There's a plus 2 at the back.
Okay.
Yeah, the black color plus 2.
Okay.
Yeah, that's the pattern. Okay, good. That's this question. Volume of revolution done. This one is part 2 over here. And then part 3 is this guy over here, part 3. The answer is 20.3 for part 3. Okay, moving on. Let's go to the next question. So this is question 13 done. We're gonna move on to, let me see. Now is the time for me to introduce the new topic. Not exactly a new topic, you should already know all this. Let me just prep my slides a bit. I need to get it to load. It loads very slowly. Okay, that was a preview. Okay, let's begin the lesson. This is a topic known as Riemann sum. Okay, Riemann sum. It is not mentioned in the H2 math syllabus, this Riemann sum, but basically it's the main idea here is whenever we want to, okay, for integration, we know two main ideas, right? Two main ideas, namely, you already know this from O level.
Yeah.
Two main ideas. When you start with a function, you differentiate it. You get to f prime x. You can work backwards by integrating. So in other words, the first idea is integration is the reverse of differentiation. You know this, right?
Yeah.
That's how the reverse chain rule works. Reverse of differentiation. That's a very miraculous conclusion. Who came up with it? Leibniz and Newton. You know, the three forces. I mean, the laws of motion, sorry.
No.
I also don't really know. I never took physics. But basically that same guy, he came up with all this. Then the second rule is, what is it? Integration has a, or rather definite integration, the definite integral with the upper lower limit, like a, b, has a formula. It is just, you already know this formula, right? Integrate it, then you get, sorry for the fancy notation, I use capital F to represent the integral. Like for example, if you're integrating, you know all this already. I'm just being long-winded here. Let's say from 1 to 2. You get to x power 3 over 3 plus x squared over 2. This guy here, the integral is what I call the capital F. Then this original is what I call the little f. Is that okay? Then what do you need to do with this? You need to sub in the limits 2 and 1. So in other words, if I call this capital F of x, sorry for the notation, but please bear with me. The capital F is representing the integral here. Then you just have to sub in the 2, sub in the 1. It's really just f2 minus f1. Do you notice that?
Yeah.
Right? So fb minus fa. So that's the second thing you know about integration. These two ideas, if you go to university, you have to prove it. The prof will explain to you step by step why this is true. But for now, we just need to memorize it. You just need to memorize it. Then the main idea here is, before you find out, but before that, that is the main conclusion. I'm just gonna get rid of this. The main idea that you need to know from integration is that it is asking you to find the area under a curve. And this is the starting point. This is a definition, actually. Definition means you don't question it. It's a starting point. But since integration is finding area under a curve, how can it be linked to differentiation? Why would it be the reverse? It doesn't make sense, right?
Yeah.
It will make sense if you're in university. For H2 math, you don't need to know. Okay, I'm sorry, but I'm not gonna explain this. It's called the fundamental theorem of calculus. You can go look it up if you want, but I don't recommend it. Not tested. You just need to memorize. It's a reverse, and you already know this. But so we should put our attention for this topic. What we're going to do now is we're going to bring our attention back to the definition of the integral, which is the area under a curve. Without questioning why the theory works, don't go and question this. We try to find the area under a curve, but we do it in a more indirect way. Specifically, we're going to find the area by estimating it with rectangles. But before that, let's just figure out what's the exact area first. Let's say we have this example of a y equals x squared plus 1 function, little f. Then we want to find the exact area between the curve from x equal to 0 and x equal to 60. Can you see x equal to 0 here and x equal to 60 here?
Yeah.
Then there's a region here. We want to find the exact area. How do we do that? We take the definite integral. This guy. Integrate x squared plus 1 from 0 to 60. So on and so forth, you know how to integrate. X cubed over 3 plus x. Sub in 60, sub in 0, minus. Then you eventually get 72,060 units square. I calculated beforehand. Not important. You know how to do this. Yes?
Yeah.
Now, the more challenging part is we're going to now try to approximate the area under the curve by using rectangles. So here's what I did. From 0 to 60, let's say let n be referring to the number of rectangles I want to use to approximate this. There are a few ways that you can approximate it. You see, the area of a rectangle is very easy to calculate. It's just length times breadth, right?
Yeah.
Or breadth times height. So here, let's see, this original region versus the current region I concluded, the A1 plus the A2. You can see, right, the A1 and A2. Do you notice that this A1 plus A2 is a very bad calculation, bad approximation of the exact area? I eventually get to 27,000. Later, I explain how I get 27,000. It's a lot smaller compared to the actual area, right? You see, before it was this one, after it's this one. Before, after, before, after. What's the difference? The difference is over here and over here. Can you see?
Yeah.
That's the gap. So that's why this area under the curve is an under approximation. There are other ways to approximate the area. You could have drawn a rectangle like this and like this, right? You get this entire region and this entire region. That would be what we call an over approximation. Okay? Does it make sense? Why is it over? Because there's this extra region here and this extra region there. Extra. So this is what I call the left endpoint method. And there's another guy that I just drew in highlighter. It's called the right endpoint method. Why do I call it that? Let's just focus on the left endpoint. Look at this rectangle, the first rectangle. Notice that there's a top left corner, top right, bottom left, and bottom right corners. Yes, the 4 corners of a rectangle.
Yeah.
Here I draw in black circle. big this circle here is the top left corner of the rectangle, right? We call this the left endpoint approximation of the area under a curve. Left endpoint, right? Because you use the top left corner. Now let's try to figure out whenever I have the exact area 0 to 60, and I want to approximate it with two rectangles using a left endpoint approach. That means that I would have to be, I have to be very creative and be tricky. Here, the trick here is that whenever I have two rectangles, I want to make sure that the width, this base here, is equal in length. So it will make sense to split it out as 30-30, right?
Yeah.
60 divided by 2. Or in other words, there's a fancy formula for this. This 30 is what we usually denote as delta x. But to be honest, you don't really need to know what's delta x. Delta is a Greek letter. It means change. Then x means because it's on the x-axis. So we can think of it as the change in x. The change in x is 30. The change in x is 30. How do I get this 30? There's a standard formula, which is b minus a over n, where 60 here is the b, 0 there is the a. Small and big. You take big minus small divide by number of rectangles you want. In this case, two rectangles. So each width of the rectangle must be 30. Okay? But how about the height? Right? If you want to find area of A1 and A2, the two rectangles, it's just width times height. Width times height. Width we know is 30, so times something. Another width 30 times something. But how do you find the height? What you realize is that here I was very tricky. I was very creative. The left end pointer is the top left corner of the rectangle, but it is also a point of intersection with the graph, right?
Yeah.
So if it is a point on the graph, doesn't it mean I can just sub in x equal to 0, then I can get its corresponding y coordinate? In other words, let's focus on this particular point. You notice that the x coordinate is 0, right? So what's the y coordinate? It's just 0, f of 0, where reminder y equals f of x equals x squared plus 1. So that means I just sub in x with 0, I get 0 squared plus 1, which is just a 1. But what do I know about y coordinate? I tried to get you to focus on this when I was talking about volume of revolution already. Y coordinate is really just this length here, right?
Yeah.
Which means that it's the height of the rectangle. Y coordinate is height of rectangle.
Oh.
Height. Then the what do you call this? The delta x. The delta x is the base. So now that I have the height of the rectangle, I also have the base of the rectangle, the 30. Can I find the area of A1?
Okay.
What would it be?
The 30 times 1.
Exactly. So that's exactly what I did over here. I just use some fancy notation. Total area will be A1 plus A2, but delta x times F0, which is delta x times F0 plus F30, which is really just, if I wanted to, I can write it as 30 times 1. And the other guy, it will be 30 times f of 30. Let's figure out why it's 901. Let's figure out why it's 901. Same thing here, we focus on the rectangle A2. What's the x coordinate here? What's the x coordinate here?
60.
No. This guy here. 60 is here. What's in the middle?
30.
Just 30 only. So that's why the corresponding left end pointer, which also intersects with the graph of y equal x squared plus 1, must have a coordinate that is 30, something. F of 30. What's f of 30? Just remember the notation for f of x is x squared plus 1. So when I say f of 30, I mean sub in x equal to 30. Sub in x equal to 30. Then you get 901. 30 squared plus 1. You can calculate on your own calculator, you get 901. So that just means that this height here, the y coordinate is the height here, is 901. And I have a base here, which is 30. Can I find the area of rectangle A2 now? Can. What will it be?
901 times 30.
Very good. So that's exactly what I have over here, 30 times 901. But I use fancy notation because I want you to see the general pattern. Delta x multiplied by f of 0 plus delta x times f of 30. It's just 30 times 1 plus 30 times 901. Area of rectangle plus area of rectangle. part, okay?
Yeah.
Can at delta x represents the width, or maybe I should label this width, or rather the base, right? Base times height. Area of a rectangle is just base here, height there, area equals base times height. In case you don't know this, I'm sure you know this. And here it's base times height plus base times height. But notice there's a common factor of 30 or the delta x. I can factor out, right?
Yeah.
Just like your table question in sequence and series. Geometric series, arithmetic series, you need to draw table, right? You need to see pattern. Same thing over here, you also need to see pattern. Delta x factor out. Then what are you left with? It's always the width that is factored out. Because remember at the very beginning, I said I was very clever and very smart and creative. I came up with the idea of splitting up the rectangles. I start off with two rectangles and I decide that I want the width of the rectangles to be equal. Need to memorize this creative step. Then that's why you have 30, 30. Then I can factor out the common factor. Okay, good. After factoring out, what do I get? I get F0 plus F30. Remember what is F0 and F30? It's really just the 1 and 901, right?
Yeah.
Which is what of the rectangle? What of the rectangle? These guys.
The breadth.
Okay, similar idea lah. Height lah. I call it height. Base times height. Or maybe, yeah, I just standardize. I don't call it width, I call it base. It's the height, right? Do you agree?
Yeah.
The height, okay, good. So it's the sum of the heights. So maybe if I just rewrite it in English, it will be base times height 1 plus height 2. Height number 1 and height number 2 for a rectangle A1 and rectangle A2. Yes? Okay, good. That's a general formula. If you can remember it like this, it's already very good. Just remember this. You can factor out the base, then times height plus height. That's with two rectangles. Eventually, blah, 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 you sub in, you get 27,060. This is 30, that's 1, that's 901. Just type in a calculator. Can? That's with two rectangles, n equal to 2. What do you think I'm going to do next? I started with n equal to 2. What do you think I want to do next?
N equals to 3.
Exactly. That's what I'm going to do next. Oh, sorry. I just made it a bit. Why is there a repeated side? I'm not sure. Okay, so yeah, n equal to 3. Exactly. That's what I did here. Okay, so now I change it to 3 rectangles. What happens? That means your equal width. Remember the creative step? The not width, the base must be equal length, right? So now it changes to 20, 20, 20. Because we are trying to find from 0 to 60. We're trying to approximate the area, exact area under the curve. We're trying to approximate it by using rectangles. Here I use the left endpoint approach so that I will underestimate the area for this particular curve. Left endpoint approach, a very fancy name. But basically, top left, top right, bottom left, bottom right of a rectangle. Let's say rectangle A1, right? We just focus on the top left corner of this rectangle. That's what we call the left endpoint approach. Don't need to know, just need to know the picture. So how did I get 20? What's the formula to get 20? It's this formula over here. Delta x equal b minus a over n. Big number minus small number, divide by number of rectangles. You get 20. Is this clear? 20?
Yeah.
So 20 plus 20 plus 20 or 20 times 3 will give you your 60. That's why I get 20. That's why I use 20. But now if you want to approximate the area under the curve, it's really just finding out the area of these rectangles, which is A1 plus A2 plus A3, right? Then you already know that area of a rectangle is base times height. So I just fill in the blank. Base times height plus base times height plus base times height. But hey, why do I pick F0, F20, and F40? Why? How did I get these?
Plus plus 20.
Yes. Because these guys are what we call the what of the rectangle?
The height.
The height of the rectangle. Can you see that F0 is the y coordinate of the left endpoint, which is the height of rectangle A1? Can you see that in rectangle A2, the height of rectangle A2 is f of 20, which is the y coordinate of this left endpoint? Can you see that in rectangle A3, the height is f of 40 here, which is the y coordinate of the left endpoint? Y coordinate of the left endpoint.
Yeah.
Can So that's why we get F0, F20, and F40. And the reason why we plus 20 and plus 20 is because of the width. Okay, you always start off with your 0. Okay, it actually depends on the question. But you start off with the A value here. This is what I call the A. I call this the B. You always start off with an A here. Then this one will be A plus 20. This one will be A plus 40. But what's the pattern? How do you get to 40? Isn't that just 20 times 2?
Yeah.
But 20, isn't it just 20 times 1? Then this one, A plus 20 times 0. Can see or not? 0, 1, 2. Then what do you notice? This is 3 rectangles, but here you end with 2. Isn't 2 just the same as A plus 20 times 3 minus 1? Correct or not?
Correct.
So you always start off with the number of rectangles, but you minus 1 for the last value of your x. Can see a pattern? We focus not on the f, but we focus on what you substitute inside the f. The 0, the 20, the 40. Maybe I should change my arrow. I'm focusing on the x coordinate. Here, and here, and here. Okay, but anyways, I'll pay our attention back to this guy here. How do you estimate the area? You just take A1 plus A2 plus A3. So it's base times height plus base times height plus base times height. Factor out the common base of delta x. We get delta x times F0 plus F20 plus F40. This part okay? Okay? Can Then now we just sub in. Delta x we know is 20. F0 we can calculate is 1. F20 is 401. F40 is 1601. Okay? You can check it yourself. Just sub in the x with 20, x with 40, or x with 0. Then square it plus 1, square it plus 1, square it plus 1. You'll get these. Then you get 40,060. Can? What do you notice? The exact, let's zoom out first. Let's go to the exact area again. Recall what was the exact area? 72,000 something. Then we use 2 rectangles, we get 27,000. But now we increase to 3 rectangles, it became 40,000. So let me just record down. We went from 27,060 to 40,060, which is almost reaching the exact area of 72,000. 72,060. Okay? 60. So what do you know? What is the main pattern you should notice here is that when you go from 2 rectangles to 3 rectangles, the answer is getting closer. You notice it's getting closer to the exact area?
Yeah.
That's because the blank space here, here, and here, that is the under approximation, the difference, or what we call the error. Is getting smaller. You notice that?
Yeah.
So if you keep on, so now I talk about n equals to 2 rectangles, then now I talk about n equals to 3. Just now I talk about n equals to 2, now I talk about n equals to 3. What do you think I'm gonna do next?
Like n equals to 4.
Then so on and so forth. I actually didn't bother drawing n equal to 4. Then n equal to 5, n equal to 6, n equal to 7. You can do the same thing on your own. But I just jump straight to n equals to 8. Okay? And I labeled ahead of time already, because it's a waste of time if I do it in class. So now what we do is we find out the area of the total area of this rectangle. We'll just get delta x and f0 plus f of 7.5 plus f of 7.5 times 2 plus f of 7.5 times 3, so on and so forth until 7.5 times 7. You always times 7, which is 1 less than the number of rectangles. Here n is equal to 8. Then the delta x, why is it 7.5? Because of the formula here. Formula here, b minus a over n. Big number minus small number, divide by 8. You take the total width of 60, which is 60 minus 0. Then you divide by the number of rectangles. 8. Can? 7.5. So that's why we get this formula here. Just the area of a bunch of rectangles, base times height plus base times height plus base times height plus base times height, all the way 8 times. Notice there's a common factor, delta x, so you factor it out. Then you're left with delta x multiplied by the sum of each height. Correct or not?
Yeah.
The f0 plus f7.5. This is the height. I think by now you know already. It's quite boring already. These vertical lines is really just the y coordinate of the left endpoints, which is the height of each rectangle. Yes?
Yeah.
So that's why we got sum of each height. But here I wrote it as a fancy formula in terms of sigma notation. Can you understand what's going on here? Let me explain. Okay. Here I already labeled all the coordinates. Just see the pattern. You start with 0, then f of 0. 7.5, f of 7.5. 7.5 times 2, then f of 7.5 times 2. 7.5 times 3, f of 7.5 times 3. 7.5 times 4, then f of 7.5 times 4. 7.5 times 5, then f of 7.5 times 5. Then so on, times 6, then times 6, times 7, then times 7. Okay? So what's a general pattern if I want to add all these f0, f7.5, f7.5 times 2, f7.5 times 3, plus the times 4, the times 5, the times 6, the times 7. If you want to add all these together, you just need to find a general formula for the thing that is changing. Do you notice the only thing that is changing here is the times 2, times 3, times 4, times 5, times 6, times 7?
Yeah.
There's a times 7.5 in front that doesn't change. There's a factor of 7.5 in front that doesn't change. So that's why, and also the f bracket also doesn't change, right? So two things don't change, the f bracket and the 7.5. So that's why I have over here f and a 7.5. But I must start with the original value 0. Then I add on 7.5 times of I minus 1. What does it mean? Maybe if I just add a new slide. Oh, this is messy. Let me add a page. What I mean is okay, very laggy. Sorry. So what I mean is this summation from I equals to 1 to 8 of f of 0 plus 7.5 times I minus 1, right? It's really just the sum of all the heights. Let's see why it's true. I equals to 1 to 8. So you substitute 1 by 1. You just copy down the formula. F of 0 plus 7.5 times. When I equals to 1, what's 1 minus 1?
0.
So times 0. Then that means this is just f of 0. Right? F of 0. Then you add on the next one. Add on the next one. This is when I is equals to 1. The next one, I equals to 2. What do you get? F of 0 plus 7.5 times 2 minus 1, which is 1. Right? Simplify down, you get what? F of 7.5 times 1. Next one, when I is equals to 3, what do you get? F of 0 plus 7.5 times what?
2.
Simplify as 7.5 times 2. Can you see the pattern already?
Yeah.
All the way. I'm gonna skip and then I'm gonna go to I equal to 7. Then last one, I equal to 8. So f of 0 plus 7.5 times 6 plus f of 0 plus 7.5 times, no space, wait. 7.5 times 7, right? 8 minus 1 is 7. That's how I get plus dot dot dot. All this I need to shrink down as well. Hold on a second. Plus dot dot dot, and then add on f of 7.5 times 6 plus f of 7.5 times 7. Okay? This one? So this is just a short form of this guy. The pattern here is you start with 0, then you plus 7.5, plus 7.5. Isn't that just an arithmetic series? Sorry, not series, sequence. That's why you get the pattern here. First term plus the common difference d, then multiply by the index. In this case, I minus 1. Okay? Can go back to what I was trying to explain. So basically, when I say sum of each height, what I mean is f of 0 plus f of 7.5 plus all these purple guys. Then the short form is the summation notation here. Then since you have f of this expression, it just means that everywhere that had an x, you replace with a 0 plus 7.5 times I minus 1. So that's what I did over here. 0 plus can just ignore, so it's just 7.5 bracket I minus 1, bracket power 2 minus 1. And then you take the summation from I equal to 1 to 8. Do you know you can actually type this inside a calculator?
No.
Let me show you lah, okay, hold on. I need to change screen. Wait a minute. Okay, you probably haven't taken down the summation, right? So let me just show you. You can actually get the summation by pressing math, then you press up until you reach 0 summation. Enter. Then what's the variable here? We use I, but never mind, I'll just use X here. Because that's how the calculator works. You need to use variable X. Then X equals to, we had a summation from 1 to 8. Sorry, 8 of bracket 7.5 I minus 1. Bracket 7.5 times I, in this case X, minus 1, close the bracket again, power 2, then minus 1. Enter. You get 7867. Don't forget to multiply by our 7.5. That's how I get a 59,002.5. Can? Can. Gonna change back to my iPad. Yeah, so that's how we get this 59,002.5. Can? And let's just summarize the areas again. So our exact area was 72,060. Here we got to 59,002.5. Previously we had what? 40,060. And then we also had 27,060. This is with n equals to 2 rectangles. This is with n equals to 3 rectangles. This is with n equals to 8 rectangles. So on and so forth. Basically, as you increase the number of rectangles, these error terms, can you see the tiny little triangle looking shape? These errors, if you add them all together, they are getting smaller and smaller. Okay? The error is approaching 0. Can? Then that's why eventually this area will be exactly equal to our exact area if you let n tend to infinity. Have you seen this notation before? N arrow infinity?
Yeah.
Lim on top? This is what we call the limit. If we increase the number of rectangles all the way to an infinite number of rectangles, then the error terms get smaller and smaller, which basically means that you will eventually get an exact area. And in general, this is how you would write it. If let's say you just have n number of rectangles, I know this notation is a bit funny. Let's just say there's n number of rectangles, A1, A2, A3, until an minus 2, an minus 1, an. That means the total area will be what? Base times height, delta x times h1. Base times height, delta x times h2. Base times height, delta x times hn minus 1. Eventually, to last one, delta x times hn. Okay? Like maybe if I label the coordinates here, it will be x1, comma h1. Here it will be x2, comma h2. Here it will be x3, comma h3, so on and so forth until you get xn minus 2, hn minus 2. Here it will be xn minus 1, hn minus 1. And finally, we have xn, comma hn. Okay? Can? The hn, h whatever, those are really just the f of whatever, right?
Yeah.
It's just f of x1, then f of x2, then f of x3, f of xn minus 2, f of xn minus 1, and then this hn is f of xn. So that means that I can replace h1, h2, hn minus 1, hn with fx1, fx2, fxn minus 1, fxn. Then I didn't bother writing it down. I just write down sum of each height because that's the interpretation, right? The f value is the height of each rectangle, remember? Then that means I sum up each height, which means I can sum up f of xr, where r goes from 1 to n. Can this formula? Can I set? xr and then r goes from 1 to n?
Okay.
The xr is similar to the formula we had in the 8 rectangles. This is my xr. xr equals to 0 plus 7.5 times r minus 1. Okay, I just changed the letter I to R.
Mm.
Okay, yeah. In general, it's just XR. That's for n rectangles. But now if you want an infinite number of rectangles, what do? We replace the n with infinity. But technically, infinity is not a number, it is an idea. So we need to introduce this idea known as a limit. So you just pretend that n gets bigger and bigger and bigger. Infinity is bigger than all other numbers. So technically, it's not really a number. You can't do plus minus times divide with infinity. So the notation for it will be this. You take the limit as n goes to infinity if you want an infinite number of rectangles. Okay, here I shouldn't stop at n. Actually, I should go on to infinity or something. It just goes on forever. Many of these rectangles. Okay. Then eventually, this will be exactly equal to the. If you can just let me rearrange this notation a bit. Lim n tends to infinity. The limit as n tends to infinity of the summation of fxr as r goes from 1 to n multiplied by our delta x. This is exactly equal to the integral of f of x dx from x equals to 1 to 60. Okay, where delta x is, I gave a formula here, or b minus a over n, or 60 minus 0 over n. Do you notice that they look very similar? Infinity, then got s, delta x, then got dx, fxr, then there's a fx.
Yeah.
Right? Because this is actually our definition. This is our definition. You will learn this in university, but if you're not studying maths, it's okay. Just need to know this roughly. Okay, take the limit of the sum of the heights multiplied by the base. Basic idea here is, maybe if I rewrite it in English so it's easier to remember, limit as n goes to infinity of the base constant. Maybe I should write down constant base. Remember the examples I gave you, right? 30 when it's 2 rectangles, or 20 when it's 3 rectangles, or 7.5 7.5 times when it's 8 rectangles. That's what I mean by constant base. That's the delta x multiplied by sum of all heights. That is the general formula. And you take the limit as n goes to infinity. All right, ready? Can you remember this? Take this down, the English one. The math notation, if you don't understand, never mind. Just remember this idea. Limit as n goes to infinity of constant base multiplied by sum of all the heights. I'm trying to simplify it for you. Okay, good. Now we can begin. Now that we know this pattern, we need to do the actual examples. Let's look at question 8. Let me copy down first. Okay, let's read the question. So question 8, the diagram below shows part of the graph with rectangles approximating the area under the curve between x equal to 0 and x equal to 1. So x equal to 0 is here, x equal to 1 is there. They show you 4 rectangles. They want you to prove that the total area of the 4 rectangles shown may be expressed as the following formula: 1 over 5 cubed summation of r squared, r goes from 1 to 4. How do you do that? They just ask for 4 rectangles. I'm sure you know how to do that because I already demonstrated to you how to deal with 8 rectangles, right? This should be easy, right? Right? Left hand point. They already gave you the x coordinates, 1/5, 2/5, 3/5, 4/5. So your procedure should be to label the y coordinates. Sorry, the what do you call it? Coordinates of the point. Those left endpoints, can see?
Okay.
Now, sometimes it may not be left endpoint. It may also be right endpoint. It depends on the question. Here, the diagram gave us left endpoint. But in general, what you should identify is the point of intersection between one rectangle and the curve, which in this case, coincidentally, is the left endpoint of the first rectangle. Coincidentally, is the left endpoint of the second rectangle. Coincidentally, is the left endpoint of the third one, and the left endpoint of the fourth one. It was by design. So let's just by design of the question setup. So 1/5, 2/5, 3/5, 4/5, then 5/5, which is 1. The equal with here, delta x is equal to
1/5.
1/5, exactly. So good, you can identify that. 1/5, 1/5, 1/5, 1/5. Then in this case, how do you find the area of a rectangle? The total area of these 4 rectangles, sorry. Remember the formula? Limit, that's for the, sorry, when I said the limit formula, that's for the exact area. Exact area equals to limit of the constant base multiplied by sum of all heights. This is for the exact area. Here, it's a much simpler case. You don't need the limit because it's just 4 rectangles. So can you figure out how to form an equation, expression for the area? These points here we need to label, right? X and Y.
Yeah.
Right, you remember the demonstration I showed you? I labeled every single point, one by one.
So I need to sub in the 1/5 into the equation, like every of the point.
Correct. Not just 1/5, also 2/5, 3/5, 4/5, and just 4/5, just 4/5. So let's figure out the coordinates of the point. X is 1/5, then this one will be, this is y equal x squared, by the way.
1/25.
Don't simplify it, just write down as bracket square.
Oh.
Then the second one, 2/5, comma,
2/5 square.
and then 3/5, comma,
3/5 square.
4/5, comma,
4/5 square.
5/5, comma.
Oh.
Don't do it.
1.
No, don't do it. Because here, it's not part of the point already. If it's x equal 5/5, it means we're trying to find a 5th point here. That's not relevant anymore.
Oh.
So what's the purpose of labeling all these points? It's for you to identify y, the f of something, the fxr, f of xr. Those are just the height. Right? These guys are the height. So what do you need to do? The formula for finding area of a rectangle is just base 1/5 times its height 1/5 square. That's the A1. Let's call it A1, A2, A3, and A4. So I'm just doing the same procedure again, but now I manually write it out. A1. Then you add on A2, A3, and A4. So it will be plus 1/5 times base of 1/5, then the height is
2/5 square.
2/5 square. Next one, for A3, what would it be?
1/5 times 3/5 square.
Fourth one, A4?
1/5 times 4/5 square.
Any common factors?
1/5.
1/5 can factor out. What are you left with? Okay, you can write it out step by step first. 1/5 square plus 2/5 square plus 3/5 square plus 4/5 square. Yeah? But here, look at the question. What did they ask you to do? Show that it can be rewritten in this format. 1/5 power 3. Not 1, power 3. Summation of r squared from 1 to 4. How? This one, maybe it's time to expand. But expand it carefully. Don't just rewrite as 1/25. Write it as 1 square over 5 square. The other one, 2 square over 5 square. Can you try the next one?
3 square over 5 square.
Very good. The 5 square has more value than 25. Just now you started off by telling me this is 1/25. Not useful. 25 is not important. 5 square is more important. Why? Because you can now see the relationship between 5 and 5 square. How is it related to 5 cube? We do it later. I think you can see the relationship already. 4 square over 5 square. Last one, right?
Yeah.
How?
Can take out the 1/5 square.
Good. Then you're left with 1 square plus
2 square plus 3 square plus 4 square.
Good. So 1/5 times 1/5 square become 1/5 cube. Multiply by, in general, this will be summation. Just follow. If you are lost and confused, just copy the question. Sum of r square, right? Where r is 1 square. 2 square, 3 square, 4 square. So that means R equals 1 to 4. Do you understand?
Yeah.
Okay, right? You're just subbing in the R with 1, with 2, with 3, with 4. Okay? Therefore, shown. Done? Clear?
Yeah.
Good. Okay. That was part 1 only. Let's move on. Part 2. Yeah, so that's why I recommended you to not do this question. Quite difficult. You need to see pattern. You need to know summation. Your sequence series haven't go through, also quite weak. Yeah. Then many things to go through. Okay, so part 2, let's just do it together. In general, when the x-axis between x equal to 0 and x equal to 1 is divided into n equal parts, the area under the curve may be approximated by the area capital A of n minus 1 rectangles, each of width 1 over n. All right. Why is there only n minus 1? Let's see. I think what they mean is something like this. You see, 1, 2, 3, 4, 5 parts, right?
Yeah.
And then how many rectangles? Only 4 rectangles. It's always one less. It's a bit like your ruler. Here's 0 cm, then you got 0 0.1, 0 0.2, 0 0.3, 0 0.4, then 0 0.5, then 0 0.6, 0 0.7, 0 0.8, 0 0.9, then 0 0.10, which is really just 1 cm. Notice how many tick marks are there. We call these tick marks. 11, right?
Yeah.
But there's how many spaces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. Even though there's only 10 cm, 10 millimeters, which is 1 cm, which is 10 spaces basically, but you need 11 tick marks. You get the pattern?
Yeah.
11 tick marks to represent 10 millimeters or 10 spaces. Yeah, I think that's what they meant. You have n minus 1 going on. Sorry, n minus 1 going on. If this is n equal 11, this will be n minus 1 equal to 10. Or n minus 1 rectangles. Then they tell you each of width 1 over n, or the base. Now take note that there's a special formula here for the sum of r square. It's a standard formula. Okay, n over it will be the same as this guy. Let me just demonstrate to you what they mean by this formula. So this formula here, how does it work? So let's say, for example, we want sum of r equals to 1 to 3 of r square. That's just 1 square plus 2 square plus 3 square, correct? Yes? Mic test, are you there?
Yeah.
Can, do you need, okay. Is it okay if we have like a 5-minute break?
Oh, sure.
Before I continue, because it's been like quite long. I need to use toilet, sorry.
Okay, okay.
Okay,
Yeah.
5-minute break, we'll come back. Mic test, mic test.
Yeah.
Okay, 10. So yeah, what was I saying? Yes, I was just trying to explain this formula to you. Sum of r square from 1 to n is just that formula on the right hand side. I'm demonstrating for the case where n is equal to 3. So it's just 1 square plus 2 square plus 3 square, you get a 14. But let's see whether, oh my goodness, n equal to 3. So let's see whether this formula holds true. The n over 6 times n plus 1 over 2n plus 1. Does it hold true? Is it the same? Will we get back to 14? Let's see. It's 3 over 6 times 3 plus 1 times 2 times 3 plus 1. Type in a calculator, what do you get?
6.
Huh? The whole thing. 3 over 6 times 3 plus 1 times 2 times 3 plus 1.
Oh. 14.
It's the same. Is it a coincidence? Of course not. Definitely not. There is a way to show it. I'm not gonna show it here. It requires something that is outside of your syllabus already, proved by induction. It's moved to further math already. You don't need to know. You just need to know this formula. If they present it to you like this, you just use the formula. Okay, you must know how to use it. You don't need to prove it. You need to know that you can substitute n with 3. Then you just rewrite it as 1 square plus 2 square plus 3 square. You need to know how to read the summation notation. And then substituting the n with 3, you'll get to this formula here. Right? Everywhere that had an n, you replace it with a 3, then you can get 14. Same answer. That's for the case where n equals to 3, but in general, it works for all values of n more than 1, more than or equal to 1. Can?
Can.
Go back to the question. So what we have, given that this formula is true, you want to show that a is equal to this guy, and briefly explain how the exact value of this one integral from 0 to 1 of x squared dx may be deduced from this expression. How do you show that A equals n minus 1 times 2n minus 1? How do you do that? Okay. So very simple. You just need to realize that to find the total area of n minus 1 rectangles, you just need to use the formula that we derived from the total area of 4 rectangles. Maybe if I can just readjust my notes a bit. This is area for 4 rectangles. Right? Now we want to generalize this into n minus 1 rectangles. Right? How will we do it? A1, A2, an minus 2, an minus 1. How will we do it? You just have to say area for n minus 1 rectangles.
It's the formula.
It's just this formula. Okay? You follow the pattern from before. Notice that when it's 4 rectangles, you put power 4. What do you think it happens if I change this to plus 5? Yes, it's using the formula. We already used it here. But I think there's a faster way since they already gave us a hint to do this fun part. But I want you to generalize from this formula instead of using the standard formula I told you. Constant base multiplied by sum of all heights. Can you see that if I just add on another A5, what will happen to my formula? What will happen to my eventual formula here? 1 square plus 2 square plus 3 square plus 4 square. What do you think you want to add on?
Plus 5 square.
Yes, exactly. So that means that this summation notation, instead of summing from 1 to 4, you just change to 5. Right? Just change the 4 to 5. If you plus A5. So in general, you realize that if you want 5 many rectangles, you sum from r equals to 1 to 5. Just now we had 4, then we sum from r equal to 1 to 4. So what happens if you want n minus 1 now? N minus 1 rectangle, so you sum from r equals to 1 to?
N equals
4 is 4, 5 is 5, n minus 1 is?
4.
Nope. Just n minus 1. Stay the same.
Oh.
Do you get that pattern? 4 rectangles, then your summation goes from r equals to 1 to 4. 4 stays as 4. Maybe I use a different color. 4 stays as 4. If you have 5 rectangles, it changes to summation from r equals to 1 to 5. 5 stays as 5. If you go to 6 rectangles, what happens? Summation from r equals to 1 to? 1 to 1? 5 to 5. 6. Yes, good. So if you now change to 7 rectangles, you take summation from r equals to 1 to?
7.
If you change to 8 rectangles, you take the summation from r equals to 1 to?
8.
If you have n minus 1 rectangles, you take the summation from r equals to 1 to?
N minus 1.
Yes, correct. N minus 1. That's it. Now you can see the pattern question. Understand now?
Yeah.
4, 4, 5, 5, 6, 6, 7, 7, 8, 8, n minus 1, n minus 1. Okay. I highlight. Okay, good. N minus 1 now. So that means that in general, the 1 over 5 cube will still remain, okay? It will still remain. You'll just get 1 over 5 cube. Oh, maybe this notation is bad. I should just label this as A. This is A equals the area of n minus 1 many rectangles. Equals to 1 over 5 cube multiplied by summation of r square, r equals to 1 to n minus 1. Right? The question is asking you find A. which is n minus the area of n minus 1 rectangles. Then in that case, you got the formula already. What do you do next? You got summation r square. So you look back at the question. What's the formula for summation r square? Given that, I hope you have the PDF of the question paper open.
Yeah.
Yes, okay. I bring it down. Copy. Paste. All right, remember the formula there?
Yeah.
So we're gonna use that. So 1 over 5 cubed here. You take the summation from 1 to n minus 1. How do you use the formula? The n n is now replaced with what?
N minus 1.
So r square still remains as r square. So that means all we need to do is to replace everywhere that we see a n with
N minus 1.
So now it becomes n minus 1 over 6 times what? Everywhere that you see a n, replace with n minus 1. So it's n minus 1 plus 1. Everywhere that you see a n, replace with n minus 1. So it's 2 times bracket n minus 1 plus 1. Can? Close the bracket again. Then you simplify. Yeah, you simplify. So this one, n minus 1 over 6, leave it alone. N minus 1 plus 1 is just n. 2 times n minus 1, this is 2n minus 2 plus 1, which straight away simplify to 2n minus 1. Now, I will want to try to simplify as much as I can. Actually, I realized I made a mistake. Here, the reason why we got a 5 is because we have 4 rectangles, which is 4 plus 1. So in that case, if you got 5 rectangles, actually here it wouldn't be divided by 5 cube. Let's say you got 5 rectangles. What would this denominator here be? 1 over 6 cube. If it's 6 rectangles, this will be, maybe I should write it down. Yeah. Here should be 1 over 5 cube. Here will be 1 over 6 cube. Here will be 1 over 7 cube. Next one will be 1 over 8 cube. Next one will be 1 over
n minus 1.
Wait, let me double confirm first. Did I do something wrongly? No, I didn't do anything wrong. Let's just fill in this blank first. Tell me what is it? 8 rectangles will be 1 divided by what first?
9.
9 cube. Okay, so let's see the pattern carefully. You go from 8, jump to 9 plus 1, right? You go from 7, jump to 8 plus 1. Yes?
Yeah.
Okay, so if you plus 1, if I start off with n minus 1 rectangles here, read the question again. They told you a of n, you want to find the value of a, show that a equals whatever, and a is the total area of n minus 1 rectangles, each of width 1 over n. So what does that mean? Here will be 1 over
n
plus 1. N, no, n what? N cube. You see, there was a cube, there's a cube, it still follows the pattern cube. 7 cube, 8 cube, 9 cube, n cube. The reason why it's n is because we have n minus 1 rectangles. Okay? Sorry, I forgot to change that part. There's another pattern here. It's not just a 5. It should be at n. Yeah, then that will be the correct formula. Okay, then now we proceed to simplify this expression. We need to eventually show it's n minus 1 times 2n minus 1 divided by 6n squared. Anything to cancel off? Yes, n cube and n. Cancel off, becomes a 2. So you're left with 1 over n squared first. Maybe I can factor out the 6. Then I'm left with n minus 1 times 2n minus 1. Correct? This over 6 take out. Does it make sense?
Yeah.
Then there you go. That's the formula already. 1 times n minus 1 times 2n minus 2. divided by 6n squared. Okay.
Mm.
Then now you want to briefly explain how do you get the exact value of integral from 0 to 1 x squared. So this is actually what we this formula here is what we have is a general form of the n many rectangles. So if you remember, the graph was y equals to x squared. Then you had like 4 rectangles, right? Just now.
Mm.
Now we are increasing it all the way to n many rectangles. So it's like a as many as you want. You can just sub in n with anything you want.
Mm.
So if you want the exact area, what do we want n to turn into? What do we want to do with this? What do we want to do with this a? Limit as
Infinity.
n goes to infinity. Exactly. So the exact area, you can maybe briefly explain this as the following. Integral 0 to 1 of x squared dx is the exact area. Don't need to spell, you don't need to say any English words. Just write the equation. Is exactly equal to the limit as n tends to infinity of a. All right. Then you just sub in the a. So it's equals to limit as n tends to infinity of the expression we have over the n minus 1 over times 2n minus 1 over 6n squared. So actually, technically, even if you couldn't derive the formula for a, you can still use it to solve this part of the question. Then how do you take the limit of our expression like this? Here's how you do it. Let's say we expand the numerator. What do we get? We'll get 2n squared minus 2n and minus n, it's a minus 3n, and a plus 1 divided by 6n squared. Can? Then what we'll do next is you try to divide by the, okay, there's a few ways to do this. First way, I show you. First way is we split up the single fraction into multiple smaller fractions. So 2n squared over 6n squared, minus away 3n over 6n squared, add on 1 over 6n squared. Okay, that's an invisible pair of brackets. Then you simplify. So what do you get? Lim as n tends to infinity, sorry, handwriting. N arrow infinity, LIM, limit. Then n squared cancel off, 2 and 6 cancel off, you're left with 1 over 3. Minus away, 1 over 2n. Then add on 1 over 6n squared. Can? So what is the limit as n goes to infinity? It basically means you replace the n with a very, very, very big number. Focus on this 1 over 2n. What happens when n goes to a very big number? 1 over 2 times 10, 1 over 2 times 100, 1 over 2 times 1000. This essentially goes towards
0.
0, exactly. How about the 1 over 6n squared? Even faster, right? Because n squared, if n is 10, then 10 squared will become 100. If n is 100, then 100 squared will become 10,000, I think. Yeah, so it goes even faster to 0. But if you reach 0, it's just 0 lah. So that means I'm just left with what? 1/3. Is it affected by the n?
No.
Then you're just left with 1/3. That's your answer. Can? So this is using the formula. But let's check. We can also integrate x squared on our own, right? We know how to do that. X power 3 divided by 3. Right, 2 plus 1 is 3. Then 1, 0. Then just sub in 1 cube over 3 minus 0 cube over 3. What's that? 1 over 3. Same answer. Yes. Can? So this is not a coincidence. There's an underlying theory behind it. But finding the area under the curve by approximating it with a generic formula and taking the limit as n goes to infinity to get 1/3 versus doing the standard way that we have been doing so far in integration techniques, it will give you the same answer because that's just fundamental theorem of calculus. You don't need to know the theorem. You just need to know that this works. Okay? That's this question. Wow, still not done yet. Let's go through another question. Let me go back. This is question 8. Okay, what's the next question? Let me see. What were the questions I asked you not to do? Question 9. Okay, let's look at question 9. Okay, let's take a look at question 9. The diagram below shows a sketch of the graph y equals to 1 over square root x. Okay, this guy. Part 1, by considering the shaded rectangle and the area of the region between the graph and the x-axis for n-1 to n, n-1 less than equal x less than equal to n, where n is more than or equal to 1, show that 1 over square root n is less than 2 times of bracket square root n minus square root n minus 1. How? You see, what are you trying to show here? This guy, right?
Yeah.
There's an inequality. So whenever there's an inequality, what it means is that you need to know that there is some sort of, you need to use the diagram to get an inequality. In this case, this and this, if you are able to see it, it's actually just referring to the area of the graph. Remember how I was talking about all these rectangles? And they are all an under approximation.
Yeah.
Under means what? Under means it's less than. The area of all these rectangles is less than the exact area. So from this inequality, you should be able to, and from understanding that concept and looking at this inequality, you should make a guess that this is probably the area of the rectangles. The approximation. And the right-hand side should be the exact area. Something along those lines, right?
Oh.
That's a key idea. So that's what we're going to do. How do we find the exact area? How do you find exact area?
Integrate.
Integrate from, look, we are trying to show by considering the shaded rectangle and the area of the region between the graph and the x-axis for n-1 less than equal x less than equal to n. They already told you the instructions for the integral to find it. Here, area of this region. What would it be? It will be referring to this region here, this shape here. Right? This entire shape. How do you find the area of that purple region? Integral of 1 over square root x dx from where to where?
n-1 to n.
Exactly. Okay, and you know that this is the exact area, the purple region. Maybe I'll just draw it on top like this. It must be bigger than, or something is less than it. What would it be? They told you to consider the
approximation.
Shaded rectangle. The approximation. Yes. So what would the area of this approximation be? This rectangle.
Need to find the y coordinate. So
yes.
It's square root of n.
Sorry, what's the x coordinate again?
The y coordinate is 1 over square root of n.
Correct. Then the x is n. Yes. Okay. Good. This is x. That is y. Okay. Good. So n comma 1 over square root n. So in this case, what is the base and what's the height?
The base is n minus 1. So it's just 1.
Yes, it's just 1. And I think what you meant is n minus 1 with bracket around the n minus 1. Yeah. A bit confusing when you say it verbally. I think this is what you meant.
Yeah.
Okay, it's 1. Then how about the height?
The height is 1 over square root of n.
Well done. Good. Okay, there you go. This is the inequality we need. This is the rectangle. Then that's the purple region that's bigger. Okay, so let's try to calculate this integral. Let's see what we get. what would this be? 1 over square root x is really just 1 over x power half. Bring it on top, you get x power negative half. Add 1, get the new power. Minus half plus 1 is positive half. So that means I'll end up with minus half plus 1 over minus half plus 1. Or if I want, I can simplify straight away as positive 1 over positive half over positive half. Bracket, bracket, n minus 1. X equals to n, x equals n minus 1. So what would this be equal to? I'll just copy down the left-hand side. 1 times, I'm sure you know that 1 can just ignore. I'll copy down the left-hand side again. Less than. Can you try subbing in? What would it be?
The n to the power of half over half minus n minus 1 bracket to the power of half over half.
Exactly. Good. So power half, I think you know is square root. Then divide by half. Like for example, 5 over half is what? 5 divided by half, which is 5 over 1 divided by half, which means you change the divide to times, then flip the fraction. K, C, F. K, C, F. Keep, change, flip. Then you get what? You get 5 times 2 over 1. What happens essentially is over 2 here, bring on top. 5 times 2 over 1. So same thing over here. 2 bring on top, you just get 2 times of square root n over 1. Right, the 2 went up. So simplify, it's dividing by 1, so I can just ignore the denominator. It's just 2 root n. Is that okay? Here to here?
Yeah, okay.
How about this other guy? Minus?
2 bracket n minus 1 square root n minus 1.
Yes, I was waiting for that. Power half is actually the same as square root. Okay, which is resembling what we are trying to prove already, right? If you look at the question. 2 bracket square root n minus square root n minus 1. Almost there, almost there. Okay, now we just factor out the 2 lah. I think you can see that. It becomes exactly what the question asked for already. Shown. Okay?
Yeah.
Okay, good. So now that we know this inequality, we can deduce that 1 plus 1 over square root 2 plus 1 over square root 3 plus dot 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 plus 1 over square root n is less than 2 times square root n. So basically, right, this question quite challenging. What you need to do is to use the formula that we deduced from before, and then you just sub in n with 1, 2, 3, or 5 all the way to the generic n term. What do I mean by that? So let me copy down the question again. You can ignore the diagram already. Just focus on the algebra. That was part 1. Now we move on to part 2. Part 2 is requesting for requesting for this expression, right?
Yeah.
Do you notice that it's really just 1 over square root n, but 1 is just 1 over square root n, but you replace the n with 1. Then 1 over square root 2 is just the same formula, but you replace n with 2. 1 over square root 3 is the same formula, but you replace n with 3. And then so on and so forth.
Yeah.
Can, right? Okay, so that means that actually we can just substitute in. So that means if we sub n equals to 1, 2, dot, 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 all the way to n, the generic nth term, then that means that we'll have, when n is equals to 1, we have 1 over square root of 1, which is just 1. It's less than 2 times square root of 1, which is 1, minus away square root of, okay, maybe I show a bit more working. Square root of 1 minus square root 1 minus 1, which is really just 1 less than 2 times 1 minus 0. Okay, I'll leave that here as 1 minus 0 so you can see the pattern more clearly later. Let's substitute n with 2 now. What do we get? 1 over square root 2. You see, I'm using this formula, but I replace n with 2. Less than, can you tell me what is it? 2 bracket?
Square root 2
minus
minus the
2 minus 1 is
1.
1. Okay, good. Leave that alone. Leave that alone. Maybe, okay, I simplify. Square root 1 is 1, right? So I'll just simplify as 1. Is that okay?
Yeah.
Good. Okay, that is n equal to 2. Now we move on to the next one. I'll just copy down the formula so it's easier for me. So now we have n equal to 1 and n equal to 2. Let's try n equals to 3. So it's 1 over square root 3 less than 2 times square root 3 minus away square root 2. Let's try with n equal to 4. Last one already, square root 4 less than 2 times square root of 4 minus away square root of 3. So on, so forth, until we eventually reach, like, let's say n minus 1. So it's square root n minus 1 less than 2 times square root n minus 1 minus away square root n minus 1 minus 1, which is n minus 2. Okay?
Can.
And then finally, n equals to n. Or do you get 1 over square root? Okay, actually, n equal to n, obviously, it will be the same thing, right? So I can just copy and paste. Right?
Yeah.
Okay, good. So what did the question ask for? They want you to show that the summation on the left is less than 2 times square root n. So in other words, this guy here, they want you to show, this guy here, they want you to add everything together. And you know that with an inequality, if A is less than B, C is less than D, you can just take A plus C, it will be less than B plus D, right?
Yes.
Left-hand side add together, reactants and products you can add together. Same thing, inequality also can add the left-hand side and right-hand side, provided the inequality is the same direction. So now that's what we're going to do. We're going to focus on all these left-hand side and all these right-hand sides, add them all together. So we end up with the left-hand side, the purple one, being 1 plus 1 over square root 2 plus 1 over square root 3 plus dot 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 until 1 plus square root n minus 1 plus 1 over square root n is less than the summation of all this. What do you notice if you add them all together? You can factor out the 2, right? Let's just factor out the 2 first to make things more obvious. Factor out the 2 first. Then we are left with everything that's in the middle. I think you're starting to see a pattern already. Method of difference. Yes. Correct. I'll just put down the plus signs here so that it's easier for me to show you the cancelling. Okay, now I factor out the 2, then I put the plus signs in between already. Anything to cancel? Yes. 1 minus 1 cancel off. Root 2 minus root 2 cancel off. I'll just draw a single line to make it look nicer. Then root 3 minus root 3 also cancel off. Root 4 and minus root 4 is missing, but it's there. It's just that it's underneath the dot dot dot. I never draw. It will cancel off. Same thing with a negative root 2. Negative root n minus 2. This guy also cancels off. Then positive root n minus 1 and negative root n minus 1 will also cancel off. What are you left with? You're left with the top cheese and the bottom cheese. This looks like Swiss cheese. You know Swiss cheese?
Yes.
Got a lot of holes in the middle. You see all the holes in the middle. You think you bought an entire block of cheese, but no, inside got a lot of holes in the middle. You got cheated. So only the top and the bottom left behind. Top cheese and bottom cheese. Okay, this is what we call the telescoping sum, or the method of telescoping sum, or the method of difference. Okay, basically a lot of the terms in the middle will cancel each other off. Okay, so simplify, what do you get? You just get the, maybe I shouldn't use purple again. I should use a different color. Hold on a second. Maybe green. Because I already used purple for the left-hand side. I don't want to confuse you. Yeah, so change that to green. And then you end up with the left-hand side, the purple guy, is less than 2 times of. Maybe I put square brackets to make it more obvious. Top cheese and bottom cheese, what is it?
It's square root n.
It's just square root n, which is 2 square root n. And there you go, that's your answer. Ta-dang. You have shown. Or deduce, they use the word deduce and deduced. Answer the question. Okay, good. Add. Oh wait, I should draw a line here and write down. Add add all together. Add all the inequalities together. Okay?
Yeah.
Good. Next one. Go, go, go. I want to finish everything. What's the next question? What's the next question? I went through question 9 already, huh? Now it's what is it? Question 2 practice questions below. Should I go through or should I let you practice?
Go through.
Go through. Faster. Okay, can. Just be careful because I didn't label it carefully. It's prac and prac. Just need to be careful of which is which. It's
Okay.
after question 13. Okay. Okay. Or maybe I'll just call it 1 and 2. Which makes it easier in case you get confused. Prac 1 and then prac 2. Okay, we're gonna do practice 1. Later than practice 2. Yeah, you can try it on your own. The video is recorded, so you can try it first. Then if you get confused, you watch the recording. Okay, so this is practice 1. Let's see. So practice 1, part 1. Let's see. Find the exact value of this integral, ln x plus 1. Straight away, you must know that ln is non-standard function. What do you need to use? What do you need to use? Certain thing.
Like formula.
Integration by parts. That's what you meant by formula, huh?
Yeah.
Okay. Draw table. So but then in table you need something times something. Here only got a single ln times what?
Times 1.
Very good. You know the trick, times 1. So 1 is considered as algebraic. Ln is logarithmic. So if you use LIATE, which one do you find the most difficult to integrate? Difficult to integrate will be L. Ln itself cannot be integrated. So that's why it should be differentiated instead. So left hand side should be differentiate, right hand side should be integrate. We got what? We got L, we got algebraic. So your U and V, let's draw the table first. U dV by dx, then du by dx, and then V equals. Draw a table like this. So what's this equal to? This U is eventually going to be differentiated. The formula is like this, U dV equals to uv minus integral v du. This is the butchered version, the corrupted version of the formula, the impure version. The correct formal version should be u of x times dv by dx of dx equals to u of x times v of x minus away the integral of v of x times du by dx dx. Very long-winded. I just get rid of the dx, get rid of the dx, get rid of the x. Then I get u dv equal uv minus v du. Okay?
Okay.
So u will be differentiated. So who should be differentiated? Should it be the ln or should it be the 1?
The ln.
The ln, not exactly. Ln of x plus 1. So differentiate, what do you get? You get 1 over x plus 1. Differentiate x plus 1, you get 1 plus 0. But 1 plus 0 is just 1, so you can ignore it. Then the other choice will be 1, integrate 1, you get x. Then what's the final answer? You'll be uv minus v du. uv minus v du. Oh, so in that case, it will be uv, which is x times ln x plus 1. What's missing? Square bracket 0, 1. The limits. Okay, the limits. Don't forget. This is definite integral. Then minus, not plus, it's a minus. Integral v du, which is x multiplied by 1 over x plus 1 dx from 0 to 1. Can? Okay, good. Now we continue. So this one, sub in, we get 1 times ln of 2 minus away 0 times ln of 1. 0 times anything is just 0. So straight away, we can essentially ignore it. 0. Minus away integral of minus in front, integrate this x over x plus 1. Wow, so difficult. How? What I realized is there's a special trick. I can plus 1, then minus 1 to the numerator. Then I split it up. So x plus 1 over x plus 1, minus away 1 over x plus 1. They cancel each other off. You're left with a 1, minus away 1 over x plus 1. This is a shortcut to not doing long division.
Okay. Then I get 1 minus away 1 over x plus 1 dx, 0 to 1. I think you know this trick. I've seen you demonstrate it before. Okay, minus away integral from this guy. So square bracket first, then 0, 1. Maybe you need more space for this. Integrate 1, you get an x. Integrate 1 over x plus 1. This is just power 1 and it's linear. So don't need to do any LFP, ln fraction formula or partial fraction. Don't need. Just ln modulus x plus 1. Yeah?
Yeah.
Okay now? Okay, good. Sub in the upper and lower limits, minus square bracket, bracket, minus bracket. Sub in 1, then get 1 minus ln of 2. Minus away 0 minus ln of 1. 0 plus 1 is 1. Modulus 1 is still 1. But ln of 1 is what?
0.
1 comma 0. So this is 0. Oh, so 0 minus 0, this whole thing is 0. You can minus away a 0, so you ignore it. This is 1 minus ln2, but there's a minus in front. So you bring it in front, what do you get? ln2 minus 1 plus ln2, which is just 2 ln2 minus 1. Can? 2 ln2 minus 1, okay?
Okay.
Good, moving on. Now this is just part 1 integration technique. Now part 2 is the one that we're focusing on. The diagram below, I didn't draw a diagram, is it? Let me see. Can I not include the diagram? Oh no. Oh no. That's no good. That's no good. I did not include the diagram. Wait a minute. Let me find the diagram first from my notes. What was that diagram? Right. I'm using the old version, that's why. No, I'm not using the old version. I just didn't copy the diagram. Sorry. Let me draw it for you on the diagram. Incomplete question, part 2. I draw it below for you. So here is the diagram that I meant for you to look at. So you got a diagram below in the following that I'm drawing. It shows the graph of y equals ln x plus 1 with n minus 1 rectangles. Let me draw it for you quickly. So here ln x plus 1, the reason why we plus 1 is so that it will pass through the origin. Makes it easier to do the question. Oops, what is that? Y equals ln bracket x plus 1. Then we have a bunch of rectangles going from 0, x equal to 0 to x equal to 1. So here's how I would draw it. Okay, give me a second to draw a few copies of this rectangle.
Okay.
So you duplicate it, you make it a bit longer like this. Duplicate it again, get a, wait. Duplicate, and then you get this. Roughly make the width the same. Because this is not drawn to scale. Eventually you get here. Stretch it down a bit. Duplicate. Move it down here, and then you need another. Maybe I think that's all I need. Okay, so this is the diagram. Here will be 1. There will be a 0. Here will be a 1 over n, then 2 over n, then 3 over n. Sorry, not accurate. 4 over n. Then here it will be, what would it be? N minus 1 over n. Then here will be n minus 2 over n. How did I get that? It's really just subtracting 1 over n. Subtracting 1 over n. Let me show you. 1 minus away 1 over n is just n over n minus 1 over n, which is n minus 1 on top, divide by n. Do you get how I got this coordinate now? The delta x is equal to 1 over n. Is it clear?
Yeah.
Then this one you can also minus 1 over n, you get to n minus 2 over n. Okay, then let's focus on the endpoints. Which points are the intersection between the rectangle and the curve? The left endpoint or the right endpoint? Top left or top right? Let's zoom in on this rectangle. Mickey Mouse. Left or
The-
right? Left
the
ear or right ear? Ah, the left ear. So I'm gonna highlight the left ear. Look at the second rectangle. Left ear or right ear?
left.
Mickey Mouse. He. Left ear. That point. Same thing for the other one. Third one also left hand point. This one also left hand point. This one also left hand point. Focus on left hand point, okay? In this diagram, intersection between the rectangle and the curve. So what's the coordinates? 1 over n, comma?
The ln 1 over n plus 1.
Yeah. Okay, then if you get the pattern, you don't need to label all the what do you call it? The coordinates. You just need to focus on the y coordinate, okay? X comma y, actually, if you get it by now, you don't need to label, you just need to focus on the y. But since you're beginning and you're still quite confused, I'll just label all of them. 2 over n, comma, ln of 2 over n plus 1. Close bracket. Next one. 3 over n, comma, ln of 3 over n plus 1. Bracket. Next one will be, second last one will be n minus 2 over n, comma, ln of n minus 2 over n plus 1. Bracket. Last one will be n minus 1 over n. Not n, it's not 1 itself. You see, look carefully. What's the x coordinate? N minus 1 over n, not 1. And comma ln of n minus 1 over n plus 1. Is this okay?
Yeah.
So you focus on the y coordinates. This one, this one, this one, this one, this one. And all the ones in between. ... Okay, so let's read the question first. The diagram shows the graph of this guy. And then I say that with n minus 1 rectangles approximating the area under the curve between x equal to 0 to x equal to 1. So there is this exact area here. What's the exact area again, by the way?
Like the area under the curve. Like integrate the area under the curve.
Which is part 1 here.
Yeah.
2 ln 2 minus 1. This exact area is 2 ln 2 minus 1. Yes, the exact area under the curve. Good. And then each rectangle has a width of 1 over n, delta x equals to 1 over n. And they ask you to show that the total area of these rectangles, denoted by A, can be expressed as the following formula. 1 over n multiplies sum of ln r plus n over n. How would you do that? A will be equals to, what's the formula again?
The 1 over n times the sum of the height.
All heights. But you can't just say all heights. Need to be more formal. So what will it be? Since they use the letter R, right? So let's also use R equals. Then we need to come up with a formula. Sum of all the heights. It's really all these purple color notations, right? How would you come up with a general formula for it? Definitely got ln involved, right? See, ln.
Yeah.
ln of what? Of what?
Uh,
What remains the same? Look inside the ln. 1 over n plus 1. 2 over n plus 1. 3 over n plus 1. Plus 1. So always plus 1, plus 1. So of course at the back must have a plus 1. How about the front? Look at the fraction. 1 over n. 2 over n. 3 over n. What's repeating? N minus 2 over?
the
N.
n.
N minus 1 over n. So that means here you need blah, 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 blah over n. Definitely need an n, right? Can you start to see the pattern now? Look for the ones that stay the same. Divide by n, there's a plus 1. Divide by n, there's a plus 1. Divide by n plus 1. Divide by n plus 1. So in general, there's always something. Divide by n plus 1. Now is the tricky part. You look at the numerator. 1 over n. 2 over n. 3 over n. N minus 2 over n. N minus 1 over n. So what would the formula here be? You need to start from I. Look at the what is the expression they want you to show. Can you read for me? A can be expressed as? All the way at the bottom, second last question. Have you found the question?
The 1 over n
Times the summation.
summation of ln r plus n over n.
Then the limit is from r equals to 1
n.
to n minus 1.
Yeah.
From r equals to 1 to n minus 1. Okay, so since they already started off with I equal to 1, let's just follow the pattern. Pretend that we already know why it should be a 1. Okay, fine, I equal to 1. So we need to sub in the formula I equal to 1, then I equal to 2, I equal to 3, I equal to 4. How can we get the pattern of 1 over n, 2 over n, 3 over n, n minus 2 over n, n minus 1? What do you think should be the letter here?
The r.
Exactly, it is r. Correct. Yeah, correct. Then you check now. If you sub in r equal to 1, you get 1 over n plus 1. Is it the, or ln of 1 over n plus 1? Is it the same as this first purple guy?
Yes.
Yes. Then if you go on, summation means you keep on increasing the r value, right? So the next value after 1 will be 2. Then you get 2 over n plus 1. Then you take the logarithm ln. Is it the same as the second guy here?
Yes.
Yes. Then your formula is on the right path already. Almost there, almost there. Now you need to know when to stop. You increase to 3, then 3 ln 3 over n plus 1. Increase to 4, then ln 4 over n plus 1. But the last guy is over here. When do you stop? What's the last value here? Started with a 1, go to 2, go to 3, go to 4, go to n minus 2, then you stop at?
So n minus 1.
So your upper limit here should be a?
N minus 1.
Exactly, there you go. Now you just need to simplify the formula. So 1 over summation, actually you don't need to put a times there, it's implied. R equals to 1 to n minus 1 of ln of, look over here, we got two separate terms, 1, 2. Look at your actual question, they have r plus n over n. I think it's obvious now, right? Just add the fraction together. R over n plus n over n, 1 is n over n. Then all together it becomes r plus n over n. Take your ln. Then you 1 over n times the summation. Is it clearer now?
Yeah.
How to show? Okay. So basically, the procedure maybe you can follow is like this. Step 1 is to identify delta x, the constant width or base. Number 2 is label. Sorry, not label. Need to identify the point of intersection between rectangles and the graph. So in this case, the intersection I have identified is the blue color. All those points of intersection, right? These points. Identify them. Sometimes it may be left endpoint, sometimes it may be top left or top right. Or top right corner of a rectangle. Okay, it depends on the question. Number 3 will be label x, y coordinates of the points in step 2. Focus should be on the y coordinate. Focus here. Then after that, use formula. A will be equals to constant base multiplied by summation of all heights, where the heights is the purple color y coordinate. Okay, right? The y coordinate is the height. Then after that is just algebra, equals algebra all the way. And you need to know how to form your own pattern. This one, case by case basis. Okay. How to form the pattern? Okay, maybe this one I need to elaborate. This is really a summation and summation topic already. It's not really relevant, but I'll just talk about it. So how do you form how to see pattern? How to see a pattern? The first thing you should look out for is repeating constants. So in our example, we had ln 1 over n plus 1. Then after that, ln 2 over n plus 1, ln 3 over n plus 1, so on and so forth until we eventually get to ln n minus 1 over n plus 1. The repeating constant, what I mean by that is the plus 1 here and the divide by n. Divide by n plus 1. Divide by n plus 1. Divide by n plus 1. You need to see that divide by n plus 1 is repeating pattern. Okay, that's what we call pattern spotting. From primary school, since primary school, you've been seeing this kind of question already.
Yeah.
Divide by n plus 1, divide by n plus 1. So this is when you need to really be able to see the pattern. Then after that, you can generalize it as, oh, it's just question mark divide by n plus 1. Then what is question mark? Then the second thing to note is the changing pattern. What's the changing pattern here? What I mean is this change, the question mark here. It changes from a 1 to a 2 to a 3 to a n minus 1. Right? The one that is changing.
Yeah.
And this will become the variable. And I usually call this guy like r equals to 1 to n minus 1. This r here is what I call the running parameter. Running. Can you see? It's like a rabbit that's running around, hopping and hopping and hopping. Running parameter. Running parameter. It runs from r equals to 1 to n minus 1. It runs and runs and runs. Just increase and increase and increase. Then this n minus 1 is the upper. Is the max. It's me. Max. The maximum. Okay? The maximum value. That's your stopping. That's when you stop. Or you can call it the stop. How I like to remember is this is the start. Okay, I'm not gonna call it max. I'll call it stop. Start and stop. Okay? Then in between there's a step size. In between will be your step size. Here the step size is plus 1. So you don't need to do anything. But let's say I change the pattern. Let's say I give another example. If I have, like, for example, I don't know, sine of 2 over x plus 1. Then the next one will be I add on. So it should be a plus sign. Sorry. Let me get rid of the dot dot dot. If I add on sine of, let's say, plus 3, so it becomes 5 over x plus 1. Then I plus 3 again, so it becomes 8 over x plus 1. Or maybe I don't put plus 1. I put something else. Let's say minus 4, minus 4, minus 4. Can you write it in terms of summation notation? Let's say I use a parameter r. How?
N plus 3.
Sorry? Sine of what
Uh,
stays the same? What's the repeating constant? Minus 4, minus 4, minus 4.
4.
So, and sine, sine, sine. So definitely need a sign. Minus 4, minus 4, minus 4 inside the bracket. So I definitely need a minus 4 in the bracket. What else? Divide by x, divide by x, divide by x. So I definitely need a divide by x. Yes?
Yeah.
Then what's changing?
The numerator.
Numerator 258, right? So that means, is it just a r here?
No.
No, because here the r only increases by plus 1, plus 1, plus 1. Here we actually increase by plus 3, plus 3, plus 3. So how do you go from 1 to 3?
Plus 2.
Times 3. No. Times 3. I actually, must be times 3. Because if you say plus 2, it will be r plus 2. Does that work?
No.
Not really. So actually, there's a standard pattern you should realize. This is an arithmetic sequence, right? Plus 3, arithmetic sequence or arithmetic series. It should always be first term plus common difference times 1. or times R, sorry. What do I mean? So this pattern here should be a 2. You start off with a 2, right?
Yeah.
If R is equal to 1. Then you have to add on, or maybe R minus 1. Then what's the common difference? It's 3. Then you multiply by R minus 1. Can you see that?
Can.
If R, then what would the R be? R equals to 1, 2, 3. So let's go from R equals to 1 to 3. Can?
Can.
Sub in R equal to 1, then you get 1 minus 1 is 0, so it becomes a 2. The numerator is a 2. If R equals to 2, then you get 2 minus 1, which is 1. So it becomes a 1 times 3. So 2 plus 3 times 1. You get 5. If R equals to 3, you sub in R with 3. 3 minus 1 is 2. So 2 times 3 is 6. Or rather, plus 3, which is plus 6. And 2 plus 6 gives you the 8. Okay, so that's how you find a general pattern. Then what I mean by step size here is maybe I should have rephrased it. It should just be A plus D times R minus 1. A is the starting value. D is the common difference. And R is the running parameter. Yeah, we should have a lesson on sequence and series soon.
Yeah.
Yeah, okay. Can anyways, where am I? We got the expression. Well, that's only the part 1. Okay, moving on. So show that the total area of these rectangles A can be expressed as that formula. We have shown it. Good. Now that was part 2, sorry. Then now moving on to part 3, we want to let n equals to 100, find A correct to 5 decimal places. That's very simple. You just need to copy the formula, okay? So let's just do part 3 at the bottom. This is A. They say sub n equals to 100, so I just follow the instruction. So A, I'll call it A 100, will be 1 over 100 times summation R equals to 1 to 100 minus 1 is 99, ln of R plus 100 over 100, close bracket. You can use a GC for this. Do you know that?
No.
I demonstrated just now already, yeah? Okay, wait. Hold on. Give me a few seconds to do this. I need to set up the screen. Oh, wait a minute. No. And then I share screen. Can see?
Can.
Okay, good. Yeah, so this is the summation. You can use the calculator again. So let's just type in 1 alpha y equals, you get frac, 1 for fraction, enter, divide by 1, 0, 0, 100. Multiply by, press the right button first, then you press math, go up. You see 0 for summation. You can press 0 straight away, or you can go up, and then you press enter. You get the summation. Here is R equals. There's a R equals. So we cannot use R in this case. We use the variable X, which is over here, the xt, theta, and n. Now this letter, this button, that's a variable. Then you go from 1 to 99. So press a 1, go up 99. Press right. You get to the formula part. What do you type in? Type in whatever you see here. ln of R plus 100 over 100. So you just go to ln. Alpha y equals 1 for fraction, R plus 100, so X plus 100. Divide by 100. Close the bracket. Goes. Oh, actually don't need to close the bracket, sorry. Syntax error, press down, then press down to number 2, go to, press enter. It will automatically bring the cursor to the place that there's an error. Oh, by the way, let's say that if, for example, I type the 1 over 100 wrongly and I want to jump all the way to the left, what should I do? Here's a shortcut. You press second, and then you press the left button. Do you notice the cursor jump immediately to the left?
Yeah.
And you press second, press right, it will jump immediately to the right. This is to help you save time.
Oh.
Second, you can also change the brightness. Second up will make it brighter. Second down will make it lower brightness. Yeah, extra. Okay, anyways, I type it correctly, so I don't need to change anything. Just press enter. And then you wait, and then you get the answer. Okay, great, good. Approximately 0.383. Wait, what did they ask for? 5 decimal place. Yeah, not 3SF. Sorry. 5 decimal place, so it's 3828 2. Okay.
10.
Good. Yeah, that is the part 3. Then hence find an approximate value for ln of 2. How? Ln of 2? How? Why suddenly got ln of 2? What's going on? So we have to look back at the diagram. So over here, if I just copy down the diagram, without so much details, still part 3. What do we know about the exact area? The exact area we found out from part 1, if you remember, it's actually 2ln2 minus 1. Okay, 2ln2 minus 1. The exact area. Okay, that's equal to the integral of ln x plus 1 dx from 0 to 1. Okay? Is that clear?
Can I just equate to the area?
Equate to the area.
I make known to the subject.
Almost there. But then you need to actually let me think a bit. Yeah, I think that's almost, yeah, that's correct. Yes. But you need to take the limit. You need to take the limit.
Oh.
I guess. But wait, actually, to take the limit, how would you even calculate it? It's a bit too difficult. Let me think. Oh. Let me think a bit. Right. Yes, you're correct. That's all there is to this question. Just equate. Correct. So an approximate value to this integral would just be whatever we found from the previous part. This is just approximately what we found to be 0.38282. Where there's 100 of these rectangles, so that's an approximation for the integral area under curve. And then you just equate them. So 2 ln 2 minus 1 equals to 0.38282. Then you just solve for ln2. Yes, make ln 2 the subject. You get 1.38282 divided by 2, which is approximately, let's see, I'll add 1 to this. I divide by 2. I get 0.69141. 2. Okay, actually you shouldn't go more, your answer shouldn't be more accurate than the least significant figure here. But never mind, we don't need to think about it. We don't take physics, so it's okay.
Okay.
Yeah, never mind. Just round off to 3SF. So in this case, you can round off to 3SF, you get 0.691. 3SF. Okay. You can also check with a calculator. ln2, close bracket. Enter. What do you get? Quite close on 0.693. Okay. Can.
Yeah.
Good. All right. Is that the last question? Is it not? Oh, was there one more? Still got one more. Oh no. You want to try on your own? Or you want me to go through?
Like I try now or later?
Like try now. Practice. Practice supposed to do on your own.
Oh, okay. That will take
But
a
then,
while.
okay, can. Yeah, go. Do it now on paper and pen. Okay, do it. I'm gonna go and get some water. I'll be back. Oh. Oh no. Oh no. Oh no. Oh no. Hello.
Hello.
Done?
No.
How about part 1? Is it okay?
I think so.
Okay, maybe send me your part 1 first.
Okay.
What do you choose for your U and DV?
The U is non-X, then the D is 1.
Okay, good. Yeah. So send me your working so far for part 1. Are you done with part 1?
Yeah.
Okay, send. I will mark it. I mean, I'll say check it verbally. Check it and reply you verbally. Okay, let's take a look. So, oh no. Yeah, no worries. I'll let you know if I cannot see. Okay, let's see. Pick U as lnx, dv x as 1, integrate 1 over x, integrate 1 x. Yep, so uv minus bdu x times lnx minus weight integral of x times 1 over x. Wrong already. X times 1 over x is x times 1 over x is. Oh, wait, sorry, you're correct. It's 1. Then you integrate 1 to get x. Sorry. Oh, I'm slow. Okay. Just a few things to note about the notation here. You got ln x bracket x. That's okay, but please make sure you got a vertical line like this, and then you put down n plus 1. Or you can also draw square bracket.
Oh,
It's the
okay.
same thing. Then for the minus integral, you also need the limit n plus 1. Yeah, but you substituted in later, so you end up with n plus 1 ln n plus 1 minus away n plus 1. Okay. Oh, okay. Right. You did some factoring already. N plus 1 times ln of n plus 1 minus away bracket n plus 1. Correct. Minus away square bracket n ln x minus away n. Correct. Very funny. How come you why do you sub in like that? I thought usually you would substitute this with n plus 1, then minus away, and then the other guy you sub in. You simplify it straight away.
What?
You substituted the n plus 1 first, right? Then you get the first pair of square bracket. N plus 1, then n plus 1 for the two expressions.
Just like I put the equation together, it becomes x ln x minus
X, right? Then after that, sub in n plus 1, minus away, sub in n. Okay, can, that's okay. That is, your working is fine. It's good. Let me just double check. I mean, the second last line is good. Let me check the last line. Minus n plus 1, then minus n plus n. Okay, cancel off, and minus 1, minus n. Okay, good, perfect, good. Your part 1 is okay. Moving on, part 2, go. Part 1 is perfect. Try part 2. You know what's a trapezium?
Yeah.
This shape, trapezium, how do you find area of trapezium?
The half
That's it.
of the common
Okay,
height
this is,
times the two length at together.
okay, can got it. Yeah, so if this is 5, this is 7, this is 2. Area is just, if you split it up, you just get 2 triangles. So half times 5 times 2 plus half times 7 times 2, which is really just half times 2 times 5 plus 7. Yeah. Okay. Okay, I need to give you a time limit already. Give you 1 minute 30 seconds.
Oh, okay.
10 seconds. Okay, time's up. Please send.
I cannot simplify.
Okay, show me your working so far. Whatever you have. Okay, I see it. Okay, let me take a look. So what we have the area of the trapezium first. So it's just 1. Good. That's the base. Multiplied by sum, then times half. Correct. Good. Then the shaded region will be, you take the entire integral, which is what we found from part 1. Then you subtract away the area of the trapezium. Okay, good. Yeah, you got it. So let me see how you simplify it. You times 2 top and bottom, so you get 2 bracket n plus 1 ln n plus 1 minus away 2 n ln of n minus away 2.
Yeah, I
Correct.
never bracket.
Minus 1. Something is wrong already. Whenever you got a minus after minus followed by a fraction, that's a super pair of brackets, right?
Yeah.
Hey, you open and you never close the bracket. Okay. Let me share screen. Here. So here you forgot to close the bracket. See, you open the bracket, you never close. So the minus actually needs to go in.
Yeah,
Okay.
I never put.
So here there's an error. It should actually be a minus ln here. Okay.
Okay.
I'm trying to draw an exclamation mark. Okay, should be a minus. So can you correct that?
Okay.
Okay. Oh my goodness. I see your algebra got error.
Same.
Where? Okay, let's go through this part here. I'll give you a hint first. I copy down what you wrote down. 2 bracket n plus 1 ln of n plus 1 minus away 2 n times of ln n, right? 2n times of ln n minus away 2 minus away 1 copy of ln n plus 1, and then should be a minus ln n. That's not the major error. It's the next line that has a major error. Here, you divide by 2 is fine, but then over here you simplify as 2n ln n plus 1. How did you get 2n over here? Oh, sorry, am I not sharing the screen? Oh my goodness. Sorry, wait.
Because the two n plus 1 minus 1.
Minus 1. But here, if you there's a 2 with bracket, so it's actually 2n plus 2 minus 1 is still got a plus 1. Okay. You cannot just cancel off minus 1 with plus 1 like that. Because this plus 1 is protected by the bracket, you need to times in. So it's 2n plus 2 times ln n plus 1 minus ln n plus 1. Factor out, then you get 2n plus 2 minus 1. So correction here should be 2n plus 2 minus 1. Or just 2n plus 1. That's one mistake. The next one, let me see. I saw another mistake. Yeah, hold on. Let me check your working first. You wrote down minus bracket 2n minus 1 ln n. Why is that the case? Oh, because of the plus L and N, right? Okay. I think now it should be slightly better. Whenever you're ready. Are you done?
Done with what?
The question. Have you shown this?
Uh,
I'm
no.
waiting for you to finish. Okay.
Oh,
Yeah. I'm not going through. I need to try on your own. I'm just giving you a hint. And whenever you're done, take a photo. Send. Have you sent it already?
no.
Are you confused?
No, I didn't.
Okay.
Yeah, I send you now.
Thank you. Two n plus one. I received it. Thank you.
Yeah, I continue from the correction that part. Because my front is wrong.
Good. Okay, wait. Let me read first. Divide by 2. 2n over 2 is n. 1 over 2 is half. Correct. Minus bracket 2n plus 1. Close bracket ln n minus 2. Divide by 2. You get minus bracket n plus half. Ln n minus 1. Good. Then you realize that you can combine you can factor out n plus half. And then you get ln minus ln. So you can just divide n plus 1 over n. Good, then minus 1. Then you simplify the n plus 1 over n as n over n plus 1 over n, which is 1 plus 1 over n minus 1. Well done. Very good. Yes. Okay. Oops. Yeah, and that's all for this question. All right, that's all for this worksheet. Okay, then the rest that I asked you to not do, you can do already.
Okay.
Do all. EJC, you can actually do everything already. I'll update you again then. You go and do those homework. Can? Okay, can. That's all.
Okay.
Bye.
Okay, thank you.
That's all.
Bye-bye.
And let me know if you got any question. I'll send you the
Okay.
homework later. Bye-bye.
Thank you. I got send you the money for Wednesday. Do you see?
I have not checked yet. I will check it and let you know.
Okay, okay. Yeah, because I forgot to send you the PayNow fee that I always send. Okay.
Yeah.
Okay,
Okay.
bye-bye.
Thank you.
Thank you.
Bye bye.